So let's look at the major applications here, right? So anytime you look at a major application, first, there's somebody goes, initially they go and do a little manual program and code, right? Think of machine translation with a parser building, think of information retrieval with the indexing and all this kind of stuff. And you explore how you measure it. You just try to get to know what's going on. And then a magic moment comes along and somebody says, this is much too hard to do by hand. Let's learn it. And then you learn it, right? And then you start saying, okay, well, we need to have data sets and evaluations, and you push it through and things. And then you eventually asymptote out. You come to a point where you say, well, it's not getting much better. I'm killing myself here. What am I doing wrong? And if you're lucky, the next thing comes along. So this is what happened with information retrieval, right? Where it was initially just keyword search. There were preferred sets of keywords and things. And then came the vector spaces, Gerald Salton, Cornell, right? Like Claire, you know him, you knew him, right? He wasn't a nice person, but he was a very effective person. They split the library community out this side and the information retrieval community out this side. And eventually the library community just died as he wanted. And now everything is information retrieval and et cetera, right? And you have the Cleverdon experiments, the Cranfield experiments. You say, well, we don't have little short lists of the most effective keywords. We just use all the words, we put them in a vector space, and we just represent our documents as little points in the vector space. We do the search that way. Okay, now, and then crucially, Donna Harmon introduced the TREC evaluations, 1990, and that became a paradigm that the whole field now takes, right? We have these competitive annual evaluations of standardized data sets and numbers and evaluations. That drives us forward. That happened there, yes? But now, unfortunately, information retrieval froze. The next thing, logically speaking, after just document retrieval is question answering. Give me the answer. Give me the summary of the answer and stuff. They never got there. They said, that's NLP. We don't do NLP. So they froze, so they become irrelevant, right? So CIGAR is busy dying, right? It's a smaller and smaller conference where ACL is busy growing because that's attacking the real problems. Okay, let's look at speech recognition. Again, in the 1960s, people were modeling the articulatory channel. They built all these physics type models with things and air movement and stuff. Nothing worked. They couldn't recognize even the 10 digits. And then somebody came along and said, this is crazy. We should learn something. So they took the speech form, they chopped it up into tiny little pieces, they put it through some transformations into some kind of sort of a vector space with Gaussian curves on top of this, and they matched that into the sort of shapes for the different phonemes, and then they put little n-gram models of phonemes together, and then they recognized little sequences. They had Viterbi search through the space to try to pull out the right sequences and to get the right spelling out, and boom, that was all these sort of Bayesian model training there, and it worked. Hearsay and Harpy, CMU, 1970s, it just worked. And from then on, almost nothing has happened in speech recognition. They basically froze, right? They didn't go to dialogue. They should go to dialogue. They do minimal little silly little dialogues, but dialogue, as we know, is difficult. It requires a lot more than just the speech wave. The speech engineers don't go there, so they froze. So they become irrelevant too. A lot of companies, but nothing else going on. Let's look at machine translation. In the 1950s, everybody wrote machine translation, right? It was on the earliest NLP AI applications. People wrote parsers and rules and neural networks, all kind of stuff. And then in the 1990s, the Brown and Mercer, the IBM group, they took the Bayesian model and Viterbi search. They took it from the speech people, they brought it in, and suddenly we have this other stuff vanishes, right? And now today, machine translation, a learned process with alignments and so on, and there you go. And then in 2010, with the Lorelei program, it went from large languages to small languages. There's still more to do, but basically machine translation is over, is my prediction, right? So that's not what's happening anymore here. So these are the kinds of course, when the neural paradigm came in, people applied this to everything. And of course, you got your 10% bump that the neural paradigm makes to everything that you did before with standard machine learning, but that's done, right? We've done 7 or 8 or 10 years of neural paradigm now. Let's look now at what advances matter and what advances seemed to matter, but basically in retrospect, who cares? Does anybody remember HPSG, GPSG, LFG, systemic functional grammars? Does anybody remember all that stuff? Do you care today? Do you care? Does anybody remember rhetorical structure theory or discourse representation theory or the Penn tree bank, prop bank, whatever, the Penn tree bank relations and things? Do you care? Do you think GPT-3 cares? No, of course not, right? We can go through all of this stuff, right? To me, this is great. It's what academics do when they collect butterflies and they fight and they have a wonderful time and it doesn't matter. Yes, but there are some things that do matter, right? There are some advances that add to the conceptual machinery of your mind, of your methodology, of the way you do your work. And those things go across the whole field and they do matter. They matter fundamentally, right? So the idea that you take representations, that NLP is mostly representation transformation. I get a representation, I transform it into another one. I may take a long English and go to a short English, I call that summarization. I may take English and go to Spanish, I call that translation. I may take English and I put English with little part of speech tags in, I call that part of speech tagging or parsing, etc. Right? It's notation transformation. The idea of learning those transformations as opposed to writing them by hand, and the idea of then using all kinds of machine, that's one step. And then going from the traditional machine learning, all kinds of bagging and boosting and all the different forms into now the neural paradigm of learning, those were two fundamental shifts that really made a difference, right? They changed everything. So in the idea of process of representation transformation, those are two shifts that one has to pay attention to, and one has to wonder what's coming. Yes? The next thing, the idea of the actual representations you use. The idea that you don't just look at the English words as they did in IR and still do in IR, but you go to features and decomposing features and share things in them. And then eventually you go to embeddings, which we don't even know what they can code anymore, right? That's a fundamental shift. There's something going on. Embeddings being continuous is a much better way of representing semantics, knowledge, words, than even distributional vectors, which is a much better way than representing little feature bundles, etc. So these kinds of shifts, this increasing finesse in representation, I think is another advance that matters. And one has to think about what comes next, right? Next one, modeling semantics. To me, this is a kind of interesting one, going from just flat representations into a vector space where you can take your object and make a vector of the object, whether it's a document, a vector of words, or whether it's a word and it's a vector of other words in a distributional sense, or it's an embedding, it's a vector of 50 positions. You throw it in a vector space, suddenly you can do clustering. You can find things. You can do LDA and LSA. Remember LDA and LSA? Doesn't really matter, right? It's just basically clustering. You can find sort of balls of these things. You can say how far they are apart from one another. That's an important shift, right? Next one, evaluation. The idea that you sort of tested by yourself and you looked into like group evaluations, standard evaluation metrics. Increasingly, also this morning we heard about evaluating evaluations, different messages. I'm busy reading a thesis from Paris, very nice work about ways of actually evaluating whole bunches of evaluations and doing something more with them. There's a lot of work, as Barbara was saying and others, and this morning, Yejin, evaluating evaluations and making them work well is really important. Everything good? Okay, fine. Okay. The methodology, you see the people there. I'm not going to talk about the people, but some of those people. These are the people who had the intuition or the luck or the something to actually do something, opened up stuff. You want to be one of them. Of course, we all do, right? So let's think about what it would take to have our nose, our sensitivity, our intuition honed to the point of looking where it is important, not just collecting more butterflies. Okay, so let's look at this little bit here and let's rewrite it around, right? At these inflection points, I think there are three kinds of things that change. It's either the technique, the process, the mapping, the transformation, or it's the representation. You're doing something with representation. You're enriching your understanding of how to capture the meanings, the stuff you want to work with, or it's the methodology. You want to measure better, you want to have better data, you want something better. To me, it comes down to always these three dimensions. Those are the for me personally, the axes under which I class the work that comes, when I see ACL or I see papers or something like that, it's either one or the other, or sometimes a little bit of both. Yes. So when we look at the history now, we can start in 1955 after the Dartmouth conference. Yeah, they tried all kind of stuff. And then came Bill Wood's ATNs, finite state technology, feature space and stuff. And that was the fundamental thing. It took the elements, words, or sets of features, which represent words or units, and it recognized that there's a structure in there and that you can actually write a machine to recognize the structure and do something with the structure. And you had all the family of finite state machines around that. That was fundamental. Next came vector spaces, as I mentioned, Gerald Salton, IR, vectors, the whole idea of taking your document, making a vector of it, throwing in one point there, doing search, all this kind of, a different kind of class, right? Next came these trainable finite state machines, hidden Markov models, the speech recognition revolution there, training and testing paradigm. Next came Viterbi, EM, putting probabilities in there for machine translation, the fundamental equation of machine translation, if you remember that pompous statement from Brown and Mercer, a little Bayesian rule, right? That sort of approach to things, which added something more, right? They snuck in annotation, and annotation, I think, is a big and underappreciated part of our field, the science of how you annotate properly and make sure you don't have bias, you don't know all the nice clean things. There's a lot of stuff still unknown about annotation. Then came sort of a quiet period with all this clustering little things like this. And now, of course, we have embeddings, deep neural networks, large language models, and hacking DNNs, right? So we have these sort of three stages that I mentioned at the beginning. Okay. Now, let's look at the advances that actually matter and sort them into these three categories. So the ones that matter in technique are the representation transformations, as I said, and the operations on the representations, what you can do, like in a vector space, what you can do with the representations or features and stuff like this. That's sort of what you do. Next is the representations themselves, what you work with, right? There's the symbolic ones, there's the feature-based ones, the semantics, the distributional, the vectors, the embeddings and things like this. And then there's the data, the knowledge stores, right? There's the lexicons and the ontologies or the triple stores or the large language models and stuff. There's different things you operate with. And then there's the methodology, how you create the rules and the transforms, how you evaluate them with different evaluation metrics and stuff, how you do automatic evaluation, leaderboards and things, and then how you create the data and remove bias and all that stuff. To me, this is a map of, sorted into these three columns, the changes, the advances that made a difference in our field from 1955 to 2025, let's say. Okay, and you can put names, all this stuff. So I did this whole long story to come to this point. Now, are we finished? Where next, right? So on the technique side, as we saw today, there's still an immense amount of exploration to be done with deep neural networks to make the techniques better. Yes, our systems are trained, fortunately, end to end. Increasingly, we just put in language and language. We don't care what happens in the middle. We just do this whole big thing like this with these transformer models. The task, if the task can be phrased at the surface level, you train an engine and it does it to some level there, right? And prompt engineering for knowledge becomes big steps to the engine was saying, and others this morning, it's step different as what you want to do to pull the knowledge out of this machine. So prompt engineering, I think, is going to be, and prompt learning and prompt optimization is going to be a big thing in the future. With respect to representations, well, we're lucky. We don't have to design representations and ontologies and features and term sets and lexicons anymore. These little machines, you give them a little randomly initialized 50 position vector, and they happily learn a vector of micro features. And there's a whole other discussion of what these things are and how they work, which can be then optimized to any particular task. Fantastic, great, super. It's easy, surface to surface, and the thing does everything. You don't have to do anything anymore, right? You can go and play around with architecture, all kind of stupid little advances that don't really matter, right? Basically, it's done, no? Embeddings and internal states, they're great. We don't understand them, so there's going to be a lot of work on trying to understand them and explain them and find heat map analysis and all this stuff is basically playing around. Maybe there'll be some ways of actually making embeddings translated into English in ways that actually are understandable and represent what's going on really. I'm not holding my breath, but we'll have to see. It may be the case that it's just going to be an inexplicable, unexplainable black box in there, as long as you know the input and output characteristics well enough. With methodology, we do the same thing. Doesn't matter what task it is, you throw your data in and out, and the machine does it for you, and you do a little optimization there. So we can still hack the architectures, and we love to do it. And there's any number of papers there that you can all ignore because they're advances that don't matter. But people believe it's really important to have another layer or a little loop or all kind of stuff like that. Forget it. No, we do probing and we do heat maps and all this stuff. Good luck. See how much you learn. Evaluations are pretty good. So you could argue that we're sort of done, right? This is sort of good. We just have a lot of butterflies to collect, but we'll get there. We got to keep ourselves busy and keep the funding coming in until the next big revolution comes, right? So this is fine, right? Is this good? Maybe it's sort of, we don't know what the features are, but hey, we're okay. Methodology is fine. We got the evaluations, we got the data sets, we started with, now we're worried about biasing and all debiasing and stuff. That's good, that'll keep us busy. That generates a whole bunch of nice talks and feel good stuff. So basically, we're done. Okay, now what next? There, okay. What next? What do you put in the box? What do you put in the box underneath these headings here? How do you use this map, these headings, to actually predict where to go next? What bothers you most about the things that you know are not right? That you would actually say, this is an advance that's going to matter, cracking this one, as opposed to butterfly collection. Right? How do you aim your research? That puzzles me a lot. A student comes to me and says, I want to work on something, and here's my ideas. And I say, there. And he says, how do you know? And I say, I don't know how I know, but how I know is this. The thing that speaks to me to this is the one that I think is interesting to work on. I don't waste my time with other stuff. I'm too old to that, right? The old people, they feel the pressure of time, believe me. Okay. Now, the answer is not larger models. It is not, emphatically not larger models, as Yejin was saying, as various people were saying this morning. If you look at this Roberta Large, 355 million parameters, right? It took about 3 GPU years. If you look at GPT-3, it is 175 billion parameters. It's a lot more. And it took about 355 GPU years. If you look at the graph there, you can see the curve goes up. How long, how much effort it takes from over the last 3-4 years, right? How much work it takes, how many hours it takes. If you project out using a sort of polynomial model to say how, when I take the squad data set for QA, for instance, and I want to reduce going up here to a 2% error rate, it's going to take 10 to the $12 to compute that, right? You need a lot of machines. If you want to go to 1%, it's going to take 10 to the, 15? And if you take an exponential curve, it's a lot worse, right? We cannot compute this. It's not larger models, okay? Now, a child doesn't compute this. My children of 8 years old know a lot more than these things, and they didn't spend 10 to the $12 in learning. I don't have that kind of money to teach them, right? So they're doing something else. We're doing something wrong. What are we missing? To me, the important thing, what are we missing? The stupid, simplistic surface-to-surface, just one thing, one transformer model isn't it. There's more. What are we missing there? No? So here are advances that I think are going to come, and they're important, and people should do them, but I'm not going to pay attention. It's great. ACL and other conferences will go, and we'll have lots of fun and come to nice places like this, and I won't go to one single paper because I don't really think they matter. But okay, LLM prompt engineering, fantastic. Go for it, guys. Cross-language transfer, beautiful, very important. Yes, absolutely. Culturally, the right thing to do. Go for it, no? Finding the performance limits, that's kind of interesting. Where do we stop? I know we're going to stop somewhere. Is it this one or this one? Find that out. That's important. Yeah, we need to know. Is it point 95 or 97? Go for it, guys. What is actually interesting, I think, is new theories, information theoretic-based theories about how these transformation engines work and why they work. That's something that's interesting. And that's something that actually I'd like to work on, but I'm not expecting it to revolutionize the field, but it's going to be something interesting. With respect to representation, as we know, these large language models don't know a lot, and they don't know, they sort of know stuff, and we don't know what they know, and they don't know when they don't know. We don't know how to actually get them to tell us or find out or to self-reflect or to drive themselves to say, I know this stuff, but here's a little thing I don't know. Let me go and do some QA or something to find out this knowledge and fill it out. We don't do that. Well, maybe we should. No, that would be good. I don't think it's going to matter much, but it would be a good thing to do for a while. Put your students on the job, right? Embeddings to explaining embeddings into English. Fantastic. Go for it. Yeah, it's all good. No, important. Faster and leaner implementations. Super wonderful. Yes, we need more. We need more. We need better. That's great. Better evaluation metrics. Always good. Data debiasing. That's very socially responsible. Absolutely. We must do this stuff. Data augmentation. All these techniques. Fantastic. All this stuff is great. And 10 years from now, when the next talk like that gets given and say, yeah, it's all, doesn't really matter. It's good, it's good. Like LFG and GPSG was good. It doesn't really matter. There's going to be something more. No? What does matter, I think, would be something like a new paradigm of computation. There was a fellow named Waterman or something at USC, he's probably retired by now, who used to compute in test tubes. He had certain mixtures of chemicals that represented certain state spaces, and then he would mix them and they would in parallel do chemistry and come up with a different thing, and that would be the answer. That's a different paradigm, not a von Neumann machine, not even a sort of a variant of a von Neumann machine, right? That's an interesting thing that might come. There may be little cells, little networks of cells that calculate things more like your brain does, not like a neural network is not really neural in any sense, right? But something like that. That would be a transformation engine revolution that changed what we do. Now, I don't know how to predict when that's going to happen. I wouldn't be surprised if it does happen. And if it happens in the next, my prediction is this phase is going to end from 2015 to about 2040. So around about 2040 is my prediction. This is going to happen. Great, we can see. All right, so we can write this down. I put my money there, right? With respect to representation, there I think is something we should and can and must be doing something. And that's learning deeper than surface type representations. The neural networks that we have today do not learn, and I'm going to give on the next two slides, then I'm done, the deeper structures that you and I all know. And I have a whole list of them. And I think we need to train them to do that in such a way that it's native to them, that they learn to generalize the way we do generalize, not the way you train them and then you have a thing in it, but that is inside the very way that they look at a problem and do something. I don't know how to do that, but that I think is the big challenge for us, because then we'll move from a little surface to surface memory, slight generalization machine into something that learns actually the knowledge indexing structures to think and represent. I have more on this just coming, right? And then the methodology, okay, well, this is the theoretical models I talked about before. If we can develop a theory-based information theoretic understanding of what's going on in our transformations, regardless of what the task and the language and the data set and everything, maybe out of that, like these information bottleneck papers that came out of Hebrew University, Tishby et al. 2010, maybe those lines we can actually do something interesting and actually give a theoretical foundation to our engineering, which we don't have, note, right? We don't have any very little theory in NLP, neither linguistics nor this kind of thing, nor anything. And we're happy. Okay, I would like more. So here is my bet for where the bigger advances are going to come and what I would like to work on. Representation deepening. The applications are fine. I think they're done, right? Human-computer interactions is one space that requires representations of dialogue, of initiative, of complex co-reference, things like, oh, that was a good thing you said. What's the that? What exactly is the meaning of the that? How do you point to that, right? All that kind of stuff. Tailoring that you can say, I'm going to give you a summary, and you tell me you don't like it because you're foreign, or you tell me you don't like it because you're 10 years old, you don't understand my words. I change my summary. I want Wikipedia to generate itself to me, and a different of the same page to my child who's 8 years old, and a different version to somebody else who's an expert in that particular area. Why does Wikipedia not do that? Can you do that? No, you can't do that. What does that require? A model of my knowledge, right? And a model of the task, how much time I have, etc. That goes back to my own PhD thesis a long time ago. That stuff we still cannot do. That requires models that go beyond the simple surface-to-surface transformations. Once you have the models, you can train the surface transformation, but you first have to think, right? We're lazy, and we're getting lazier because the machine's so easy. No, we have to think first, and this is one place you have to think. Another place is multimodal processing, right? Embeddings is really a nice space because you can throw image stuff, video, speech, tables, text, any damn thing. It's just a bunch of little embeddings in there. So it's a natural space to collect all this and to recognize that when you communicate, you don't only make text. Even in a text document, you also make bulleted lists. You also make a heading. You also make a subheading with numbers. You also make a citation. Even the text formatting, the semantics of text formatting has a semantics, which you can put into an embedding, and it should affect the way the machine understands and reproduces what it's read. We don't do that today. We should, no? But the main thing, and this is the theme of several talks this morning, is knowledge and inference. These machines have knowledge, yes? But we don't know all the things they do know. And we do prompt engineering frantically to try to find out what the hell they know. Yejin's talk was very interesting this morning about showing just all how you can squeeze it and clean it and stuff. And you get from here to here, and there's still a whole lot more missing. Where is that? What is that, right? How can we get that? I think that's going to be a really serious point, a throttling point, a problem point for us to get past our asymptotic bottlenecks, our asymptotes as we reach in the future. So here, now my final slide, is some practical tasks that I would like to work on with my students that I think are going to be advances that help toward the advanced matter. Number one is speech acts. When I give you that text up there, that picture, you know it's saying, do not use drugs or something, right? How do you know it? Because there's a picture of a thing, an injection thing, and there's a circle with a line through, right? You know the semantics of that circle. Have you ever seen an NLP or NLP plus image system that knows how to interpret speech acts of prohibition or negation doing that? Do you think it's hard? It's not hard. You just have to have the underlying knowledge of what the speech act or the polarity, the modality is, and how you recognize the pieces and compose them. It can become quite tricky, but it's not conceptually very difficult once you have the idea. There's a task. There's another task in the same sort of vein, dealing with claim frames. When you look at information extraction, here's a sentence, here's the trigger, here's the pieces, you put them together, yeah, right, okay, great. But you know, that wasn't generated in a vacuum. There was a speaker who had an attitude about that thing. And that attitude is being supported or denied or something. Everything you read and say is part of an argumentation graph. So when I was at DARPA, we introduced something called claim frame. We worked it out and we had all this stuff about, and people had to then not only read the text, but read the argumentation structure around the text to put things into claim frame. You have the outer frame, the speaker, the situation, and the inner frame, the actual little semantics of what's said. And you put the epistemic status, what the speaker is saying about that on the outer frame, and what the thing is saying inside of itself in the inner frame, and you have the argumentation, logic, all this stuff, right? Claim frames should be the way we talk about our text. Yes? It's not so hard to invent that little thing. We just don't do it. I don't know why, but we should. So we did it, okay? Here's another one, event sequences. While I was at DARPA, I inherited this program from Boyan. Learning scripts, basically. We've had scripts since 1975, for goodness sake, the restaurant script. Everybody remember the restaurant script, right? What did we do with the scripts? We said, okay, let's ramp it up. What is, excuse me, the COVID or the pandemic script? You think about it for 2 minutes, you say, there isn't a script. There's a family of scripts. There's the doctor's script. There's the patient's script. There's the researcher's script. There's the pathogen's script, right? It gets created, it infects more, it keeps going until somebody kills it, right? That's the script of the pathogen. There's the pharmacological script, there's the legal script. There's a whole bunch of scripts that interlink in lots of different ways, right? And so people started learning these scripts, and soon you'll see papers. I think there's a paper by Hong Ji here at this conference and others, where this script learning, and we'll see there's more, it was referenced this morning also, I think in Claire's talk, script learning is a fundamental necessity to start learning the deeper structures so you can make predictions. When I stop the story in the middle, you can tell me what's going to come. When I skip over something, you can tell me. Right? And it's not just that. There's more to a script than just saying this and then this and then this. Why is there this and then this and then this? Because the protagonist has a goal and a plan, and the logic of a script comes from the planning, right? Have you ever seen GPT-3 give you the goal? Does it even understand what a goal is unless it's somewhere in the text, the training, or a plan? Can our NLP systems reason about goals and plans? No, they can't. Should they? Of course they should. That's part of language. No? Am I wrong? Right? We should go and infuse our systems with this extra knowledge so that when we look at GPT-3 next, it learns somehow intrinsically to itself to learn about people's goals and all these other structures. And then some of the Mark talked about these inferences this morning too, right? Some of the entailments come from scripts. Some are psychological, some are social, some are other, right? These entailments don't come from nowhere, right? When you want the logic behind them, then you can start generating them out. Goals and plans. Next one, social relationships, right? Dee did a beautiful thesis on learning social relationships. You have a cancer support group. Who's the greeter? Who's the knowledge expert? Who's the emotional support person? Who's the newbie? Who's the old person, etc.? She took the same stuff to Wikipedia and they said, oh, who's the deface fixer and who's the fact checker and who's the spelling checker and so on, right? That technology, learning the roles of people, how they interact in societies, what expectations you put on them, how that works, that's extra knowledge. That's not unstructured surface to surface. There's knowledge in there. And then you can run the inferences and things like that. That's what we should be doing is my contention in NLP, right? Similarly, in simple sort of common sense knowledge, physical affordances. One of my students is working on a thing of recipes. And you say, well, you know, okay, prepare the cake, put the cake in the oven, and then take it out. It never said open the oven door. What happens, right? The thing goes happily on, but there's a mismatch between the post condition of preparing the cake and the precondition of putting it into the oven, and that missing thing is open the oven door. To match the post condition and the precondition, you need to have the door open, an extra little thing. You can reason your way through it as a human. These machines cannot do it. They should be able to do it. How? They should have knowledge about the physical affordances and conditions of the world, of their domains. We don't learn enough about this kind of stuff. Okay, so this is just a short list. There's more, right? But each of these things has some kind of little frame-ish or structured piece of knowledge with pieces that are there, stereotypical situations that link to other ones, that when you put them in and when you will be able to do inference, entailment, QA, prediction, all kinds of things that we cannot do today. We will not be hacking GPT-3 and asking it stupid prompt questions. We will teach it to think properly, to have that in there so it can give the right answers. No? That's what I want to work on. Thank you.
Thanks, Ed, for the wonderful talk. Questions?
Yeah, thank you very much. Great talk. Maybe this is not a question, but maybe just I would ask if you think about the way we teach, you know, whether it's NLP, machine learning, whatever, all like the related fields, what are the implications of this line of thinking on how we do pedagogy in general, how we offer like in training programs and whatnot?
I don't know. I don't know what to answer. I can think one answer when it's my 8-year-olds, and I think a different answer when it's teaching our field. I think our field has, for me, I think the students, when their master's degree, have to learn all the techniques. You have to learn to play the piano before you can compose. So have to learn all the old machine learning techniques. They have to learn a lot about representation, which they don't learn today. They have to learn a little bit about information theory, which they don't learn today. They have to learn a lot about the transformers and all this kind of stuff, which is not so important, but okay, they have to learn just basically how they work. When they've learned that stuff, then they're ready to start doing a PhD. So for me, there's this little card. Do you know a bit of basic information theory? No, go and learn it. Do you know a little bit about linguistics and representation and stuff like this? Do you know about knowledge representation stuff? No, spend 2 years learning it, etc. Then they can come in the door. I don't know if that's a good answer, but that's my answer.
Yeah, I just see a lot of tension right now. I mean, just because of the very fast progress that's happening. You know, if you offer a course today, like in 3 years, you really have to revise it somehow. And, you know, look at, you know, your talk and, you know, what Eugene was talking about, like, you know, okay, don't worry about supervised learning and whatnot and whatever. But, you know, a lot of literature actually is just on that, you know, and, you know, of course, I agree with you that we have to kind of like the students have to go through all of this literature somehow. But I think there's always this tension of like how much they should learn from the past versus, you know, what is going on and what's going to happen in the future. I just don't have a good solution to this problem.
It's a great question, and I don't know either. I think it would be terrible to conclude from this that because an advance doesn't matter, one should not teach it. You should not teach grammar because it doesn't really matter which grammar you use. They still have to understand grammar. You should not teach finite state technology because you should still teach finite state technology. So they need to know that stuff. But to me, whether they learn LFG or GPSG, I don't really care, one. And whether they learn, I don't know, LSA or LDA, I don't care, one. Yes? So I would pick one representative from each of these sort of major pieces and say, learn that, guys. Just that. That's a representative for a whole mountain of things you don't need to worry about. That's what I would do, given the limited time. Yeah. What else can one do, right? Yeah.
Irina?
Yeah, thanks for the fantastic talk. I'm here.
Oh, hello, hello, Irina. You're up next, you know.
Yes, it's a bit of a challenge, but I can connect very well to your talk. And at first I was disappointed in the first half, but then there was a happy end, and that made me very happy. So the reason I was disappointed is that among the things which you think are important and we should care of, I was crucially missing the data. And there exists meta science studies that say that data is as important as methods to innovate. And we can see it, I think, quite obviously in NLP. So with the emergence of the internet and a lot of corpus data, some innovations have become possible, or some methods could even fly. But then when you presented what you are interested to work on in the near term, it was all about novel problem definitions and data sets. So that made me very happy. But a certain gap between what you present in the first part and conclude in the second part. Do you have a comment how this integrates together?
No, you're right. And thank you. I'll go and fix the talk. No, it's true. Data is fundamental. And what puzzles me always is how out of the simple data, I can have the thing learn more than simple data. Is there like 1 more minute? Can I give another example or no? Here's a nice example. When I was, yes, no, yes, okay. So when I was a graduate student, my advisor liked to drive very fast, and he bought a new BMW because he just started a company. And he drove down to New York from New Haven, which is a 2-hour drive, very fast with his BMW. And he got a speeding ticket. And he was really angry. And so next time he bought a radar detector, and he didn't get speeding tickets. And one of the students said, "Oh, you have a canary." He said, "What do you mean canary?" He said, "Don't you know the canary in the coal mine?" He said, "What are you talking about?" Because he was not a very academic person. He was like not a nice person. He was an idiot, basically, but he was very clever, right? And so they told him, well, in the old days in the mines in England, the miners would go in with a little cage with a canary because there was carbon dioxide or carbon monoxide, and the little canary is more sensitive than the miner. So when it falls over, the miners know to get the hell out of there, right? So why was this reminding happening? We had a whole semester to unpack this reminding, right? You have an agent wanting to do something that's dangerous to them, yes? So they take an instrument which is more sensitive than they are as an early warning system. Yes? Yes? You can see the logic, right? Imagine representing an agent and a goal and danger and an instrument and sensitivity. That is a complicated structure of all kinds of little substructures. You cannot get that reminding. You cannot explain what happens in that person's mind unless you have that logic there and you can abstract away from these two things into that structure. Your mind is full of structures like this. GPT-3 has 0 structures like this. Am I wrong? You will never get intelligent behavior, predictability, remindings, explanations that really go somewhere unless you have this sort of knowledge in there. That's my puzzlement, Irina, is I don't know how to get that structure out of data. It's more. I don't know how to annotate that. I don't know how to gently tease it. So this list I put up is gentle little pieces to try to move toward that sort of structure. Ultimately, I think an intelligent person, and the way you classify and recognize intelligence is the presence and richness of those kinds of structures, how the conversation goes, how rich the remindings are, how much you learn out of all these things. Our machines are very, very stupid. We need to make them better.
Thank you.
Mark, so thanks for the talk. I agree with your goals. And they're my goals as well. My question concerns the knowledge representation that you need in order to achieve those goals. Because in the early days of the entailment graph, we prided ourselves on finding common sense knowledge that was never written down because it was too banal. But in some early experiments with scholastic aptitude tests, we've found that there was a certain kind of knowledge that we were not finding. And it involved the key piece of knowledge that we needed to solve the problem was that things can only be in one place at a time. Mm-hmm. And of course, that also is not written down. But finding it from text is very difficult. And I think finding it from the world is very difficult as well. And it reminds me of the failure of the early naive physics project, which said, we're going to think this one through and we're going to write down the logic. And it somehow didn't work. Is that an obstacle to the goals that you state, that there's a level of knowledge that is probably not inferable. It's probably produced by evolution. I think my cat knows that things can only be in one place at a time.
And they don't vanish. When you put the curtain in front of you, come back. That is my biggest nightmare of all of this. It is that it's not just the simple common sense knowledge that's not written, but you could sort of, it's the deep common sense knowledge that comes from being a physical thing in the world. When you look at the way children grow up, there's the object constancy thing at about 4 months, right? Where they say, Papa put a ball there and now he put a curtain there, but that ball is still there. I know, right? GPT-3 doesn't know this, right? How you teach that? I have no idea. But unless we have, if we could figure out those very deep primitive things and just inject them and use that to leverage up, we would be a great step further. I think this intelligence assembled in this room and in this conference next, we should spend our time doing that and not hacking stupid little, well, we can hack stupid little things too, but we should spend our time doing that more. And so I think we should have courses or challenge problems or data sets or something where that sort of thing is exercised more. I think your talk this morning about entailment and inference is moving in that direction. It's like, what can I put in there that the thing can do? I think we need more of that. I wish I knew how. That's the nightmare. Yeah.
Thanks.
Thank you.
Okay, we are beyond time, but I cannot miss Norma.
Okay, I'll be fast. With this last exchange in mind, it's interesting that you didn't include grounding in the world or interaction with the world as a key piece.
I especially didn't include it because that goes to philosophy and very complicated things. And I don't know how to do that. And so I didn't want to muddy, but it is there. You're completely right. And unless one has an embodied thing, right? When we now we assume that GPT-3 knows a lot of stuff without a body. It doesn't have hunger. It doesn't have love, right? It just sort of reads. And of course, that's just a stupid assumption, right? The fundamental logic that drives these things, it's missing. And so we can never expect it to do more than sort of pattern matching on what it's read. Real deep thinking. How we put that stuff in, whether we have to actually wire this thing to a robot, which still won't have hunger and still won't have love, but at least it'll bump into stuff, right? Maybe that's what's going to be necessary. If we can devise data sets and crucially evaluations, QA inference type evaluations that exercise these kinds of gaps, then some of the clever students will go and devise ways of representing them and doing something about that, and we'll see where it leads us. That will be a change that matters, I think. Yeah.
Okay, let's thank Ed again.
Thank you.
Our next speaker is Irina Gorevich.
But first I need to connect. All right, it's good to have a break after a very intensive Ed's talk. I'm going to present 3 perspectives on where we are at, where we should be, and how we get there. And in particular, I'm going to talk about the technical perspective, and I'm very happy I can summarize quickly because there's a lot of overlap in the previous talks. Then I will present a personal perspective, so what I want to do in the next years. And I will conclude with a community perspective, and this is a bit different from what we have heard today so far. So that's my agenda today, and as I said, where are we at? I just summarized the previous talk, so I saved a lot of work. And I think there's quite a lot of consensus regarding this. So we are with large language models, prompting, zero and few short learning. We are working on parameter efficient models like compression and for processing long documents. So the field of efficiency of NLP has been growing a lot. Then there's a strong field of research on multimodality and multilinguality. And there are a bunch of those large models being released. So these are the models released this year, and NLP is receiving a lot of attention in public. So where should we be? How far are we from the goals that we have, and what are the open challenges? Again, here there have been some talks today talking about the multilingual models, where we need to serve different language families, and code switching not served well so far. So the quality of the data has not been mentioned, but in many papers it has been shown that improving the quality of the data can lead to much better results. There's a lot of work in debiasing, but this work so far is focused on single biases, while tackling multiple biases at the same time remains an open challenge. And there's a lot of interesting work on common sense models, explainable models, continual learning, and acquiring new information, and efficient models. So how to get there? I'd like to highlight a few recent works that I find very interesting. So there's new work on multilinguality, where tokenization-free approaches have been proposed to tackle the challenges of underrepresented languages. And also this year, we have seen a major publication on an African language BERT model, which highlighted how important the inclusion of morphology is. We see a further increase in research on modularity of language processing by efficiently combining several specialized models, and approaches like adapter and mixture of experts are gaining a lot of attention. Regarding efficiency, we have new architectures for long document processing that have been recently proposed. And in explainability and interpretability, there is a fast-growing body of research on interpretable and explainable models following neurosymbolic approaches, as well as causality. We also see a lot of work that tries to incorporate world knowledge more effectively, so that the models can be more easily updated with new incoming knowledge, and efforts are undertaken to make generation more controllable. So now I'd like to switch to the personal perspective, where I like to be in the next years. And this is pretty much in line with the first main research direction proposed by Ed, which I realized during his talk. So this is about a grant that has been recently improved and is called Intertext, and funded by the ERC, on modeling text as a living object in cross-document context. So this is a topic that aligns with a human computer interaction research direction, which is basically presents the next grand challenge for NLP. So as humans, usually we read and understand documents, not as a single document, but we read and understand documents in context. And this is a very hard task for us humans. So it involves a lot of concentration. And in the recent years, we see a strong trend to texts being not only read in context, but also created collaboratively by multiple people. So the collaborative and interactive work with text is on the rise. We read and write documents together everywhere, in social networks, of course, in research, and in education. And probably it's easy for this audience to imagine a scenario where you work together with 10 other authors on a scientific paper. And this is what I call the daily collaboration mess. So you work together with other people, people make changes to the documents, you receive some comments about the document you are writing, you receive emails, or some people provide links from your document to another document, resulting in multiple external documents linked to your document, and multiple document revisions over time done by different people. So after a while, you get a headache. So it becomes impossible to keep track of all the feedback and the text, ending in a chaos of changes. So in the intertext project, we model the interaction with text as 3 core types of AI assistance. First, we draw interactive links between 2 texts, either 2 revisions or a comment and a document. This way, we can quickly move between the text and the feedback, for example. Second, we classify this feedback into different categories, for example, to-dos or questions. So this is the task of link classification. And third, we compare 2 text versions and create a summary of the changes that have been made. So the high-level goal of intertext is to switch the focus of NLP from processing static, isolated documents that a lot of research is about currently, to what we call dynamic text in context. That is a document living through time and linked with the other document, providing context for its understanding. In order to address this complex collaborative text production scenario, we need to address challenges, and they are very much in line with what has been said in the previous talk. So we need fundamental innovations in modeling, representation learning, and transfer learning. So regarding the modeling, so far there exists no general model of text structure and intertextual relationships in NLP. And though we do have some work on cross-document applications, but typically this is done in a quite narrow context. So for example, in the context of Wikipedia revisions. And in order to address this challenge, we want to look into the theories of intertextuality that exist in the humanities, where we can extract the principal dimensions of the problem of modeling cross-document relations. And we provide a graph-based data model based on this theory. And we are planning to construct a multi-domain benchmark. Next, there's the challenge of representation learning. And currently, the dominating paradigm of transformers is agnostic to the structure of the document. However, the documents usually come with a structure that we humans consume while we read and understand documents. So for example, in reading scientific papers, we might look into the conclusions or into the methods section in order to figure out the answer to particular questions. And also, as has been stated multiple times today, the processing of long documents is still very, very basic. So the innovations we would like to propose here are structure-aware transformers, structured pre-training, advanced attention, and positional embeddings in order to enrich the current representation learning techniques. And finally, in the area of transfer learning, we are quite limited today to process documents of various types and various languages. And mostly the techniques that we have are limited to sentence level. And the modularity of the techniques is underexplored. So in our lab, we have been working a lot on adapters that allow transfer learning, but so far in limited scenarios, limited to short document context and limited to combining just two adapters. So in intertext, we're going to extend this to the document level and work on language and domain transfer and explore new compositional adapter strategies. So the outputs that we expect from the project in mid and long-term structure-aware transformers, new adapter architectures, novel problem definitions and data sets, and multi-domain benchmarks for the evaluation. We have recently started working on this project already, and I would just like to present a few developments that are currently underway. So first, we started working on a text revision benchmark, which is comprised of 5 data sets and which will contain large-scale data with multi-domain document revisions with high-quality multi-grained edit annotations. And this will be available for 3 different tasks. So first, the task of revision alignment between 2 document versions. Second, for the task of edit labeling, and third, for the task of edit summarization. So among these 5 data sets that are part of the framework that we will provide in a unified annotation format, there are 3 data sets of scientific literature. Since scientific literature naturally provides a sequence of revisions and very often also comments given by other reviewers, and 2 data sets from prior work in NLP that will be standardized to enable large-scale evaluations. So the next question we are looking into right now is how to use document structure in transformers. So, as I said, transformers treat text as flat. So the idea here is that we can infuse document structure to make understanding of the document text deeper. And currently, there are some experiments underway on the task of evidence selection. So this work is in progress, and I only have evaluation results for 2 data sets. And here, basically, we experiment with different methods of structure infusion that are shown in color, and the gray is the vanilla long document transformer. And what you can see is that the results are kind of volatile. So for some of the data sets, the structure improves the understanding of the document, and for other data sets, this effect is not visible. And most probably the structure of the documents can be more or less important depending on the nature of the data set and the nature of the task that we evaluate. Finally, we are working on transfer learning, where the 2 main sources of variation in language and domain. So, for example, if we have English books and we want to transfer to health records, so we do not just transfer language or just transfer domain, but we want to change these 2 parameters. State-of-the-art in transfer learning is held by adapters and similar models, and they have been used either for language or domain transfer. The main challenges to solve here are in the first place to create large-scale evaluation data to drive the development of this technology. So we are working on creating a multi-domain, multi-language benchmark that would allow us to measure cross-domain and cross-language transfer simultaneously on a set of generic NLP tasks that apply across domains. And next, we need technologies that explore the modularity of adapters, so we can combine multiple adapters without hurting their performance. So finally, we are interested in long and cross-document context. So we want to apply this technology to understanding the relations between two long documents in the long term. So next, let me talk a bit about something completely different, but somehow also interrelated to the cross-document understanding. That's what I call the community perspective. So what is it about? Considering the community perspective for the future of NLP means considering peer review in all its complexity. So right now, I'm on the ACL exec and involved in some community strategy. And since a couple of years, I've got interested in this topic. Can we use NLP techniques actually to improve our community internal processes, since all of us take part in community decision-making, and of course, many of us are affected by it. So peer review is a key process in community decision-making, and it would allow us to be more transparent what is happening with the field and hopefully make better decisions. So with this goal, a couple of years ago, I think it was 2017, together with some colleagues, I have started an initiative on collecting peer reviewing data for ACL, and it's an ongoing effort, as many of you might be aware if you have ever used ARR. So why this is interesting beyond the community level interest. So this is a very interesting application domain, which is so far under-researched due to the unavailability of this very sensitive data. And this domain is very challenging because it involves complex expert knowledge. So it provides very challenging and forward future-looking scenario for understanding long documents in a cross-document scenario. Since you have a paper typically in several versions, at least the submitted one and the camera-ready one, and you have the reviews and rebuttals and a lot of other meta information in this domain. So as I mentioned, this effort has started a couple of years ago, and we had some pilot data collections. So first, when I was the program chair for ACL 2018 and later at Calling 2020, and we found that setting up such a data collection, which is ethically and legally compliant, is a huge challenge. So the topic is extremely sensitive, as you may think. And also I was quite surprised because we had a lot of pushback actually from the community, since many people don't think this is such a great idea to collect this data and to apply NLP on it. So this is a controversial point because we are the field bringing this technology to other domains of life. But as far as us are concerned, you know, there are many, well, justified concerns. So it was a long discussion with many, many stakeholders. But at the end of the day, we learned many important lessons, and in the current EMNLP conference, there's a paper called Yes, 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 Proactive Data Collection for ACL Rolling Beyond, where we introduce an ethically and legally compliant data collection workflow for peer review data from ARR. And I'm sure most of you who use ARR, they are familiar with the questions that you receive as an author or as a reviewer if you are willing to donate your data. So this is us behind this. And the main idea is to use ARR as a long-term community infrastructure in order to facilitate data-driven processes and also provide an interesting resource for research. So how does it work? So first we ask the reviewers if they are willing to donate their reviewing report. So that's the first yes. And then if the paper is accepted, we continue with the workflow. If the paper is not accepted, we do not do anything about those papers because we consider them confidential. So we do not include them in our data collection. And next, the authors are also asked if they agree to donate their data. So they also need to agree to reviewers donating the reviews. So it turns out that the reviews also talk about the content of the paper and may contain confidential ideas. So that's why the agreement of all stakeholders is required, and everyone has a say. We decouple all these questions from the reviewing process. So there's no interference between the decision to donate the data and the reviewing as such. And confidentiality and privacy is a top priority. Otherwise, this workflow cannot be accepted by the community. So now let's have a look. So how the community responds to this initiative. So out of all reviewers, roughly 52% answered our request. And from those, 94% gave their explicit consent to donate the reviews. So basically, just to summarize, about like 50% of all reviewers agree to their data being donated to our initiative. And for the accepted authors, this looks a bit different, where we have about 30% of authors agreeing to the publication of their review reports. That leads to about 500 reviews that have been donated so far in total. So the number does not seem to be very high. However, if we compare this to existing data sets of peer review, which is a very confidential data, so this is quite a significant number. And also, since ARR is going to continue in future, we have a continuous workflow to collect over more data over time. So this is the current graph showing so how much data results from the data collection, and we are hopeful that this will gain more traction in future. Now, currently, we discard any other data which is not among the 3 yeses that we have. And of course, we have a lot more data which is in a protected repository at ACL. So this question is open right now to the community discussion, what to do with the protected data. Because this is a valuable resource, but it's not clear who is allowed to do what kind of research on that data. Of course, we cannot publish it, but maybe ACL can use it in order to support community decisions in some way. And also, we are looking into other ways how this data could be made available in a protected environment, like an enclave where people can, for example, develop their models on the freely available data, but the models could be tested on a much larger data set, which is completely private. So what is our motivation behind this research apart from the community interest? So we can envisage different intelligent types of intelligent reviewing systems, for example, to help juniors. And I can just give you two examples here. Could be pragmatic labeling of statements in the review. So, for example, we do have a certain structure of reviews, but very often when junior reviewers write their reviews, so what they write does not correspond to the structure. So with the help of this technology and models, we could improve the structure of review. So it's basically like an interactive writing assistance scenario. Another critical skill in assessing the paper is what we call skimming. So peer reviewing is typically a multi-stage reading and assessment process. One needs to manage the attention and adapt the focus depending on the paper type. So learning this skill of skimming requires a lot of experience and expertise. So the question here is, can we help junior reviewers prioritize their attention during the first skims of the paper, because we have the reviews, so we know which passages are important later in order to write a constructive review. And another type of research that could be done with this data is research on time and domain generalization. So apart from the ARR data sets that we have a number of others collected at Calling 2020 and also collected in other work that we have here. So here the research spans over time frame, and also it covers different domains. So for example, the F1000 data set is a data set that contains many different areas of science going beyond NLP. So we think that a lot of interesting research in time and domain generalization could emerge in the next year based on the availability of this benchmark. The data sets and code are available from our website. And yeah, that's it. Thank you very much for your attention.
Questions? Yes.
Hi, thanks for the talk. With respect to this last bit about like trying to model and potentially automate peer reviewing, is there a risk that we might actually gravitate towards a behavior where people game the system in order to generate like favorable reviews instead of actually doing what should be done, which just write a paper about their findings? And do you expect to run into those issues in the future? And did you think about how it could mitigate that, or if that's not a risk at all?
Well, obviously, there are many risks if you use AI in any practical domain, so that could change people's behavior. So however, we are not talking about automating the reviewing here. So the idea is that we can decompose the complex step of the reviewing process in small steps, and we can provide assistance to humans reviewing the paper to facilitate those steps. So this is an expert task comparable to fact-checking, for example, and I think it's out of questions we can automate it, but we can facilitate the work of humans in specific points that mean a lot of work for them. And of course, there's a risk of various biases, both technical biases and behavioral biases that could emerge as a result of this technology, and that we need to effectively counteract if we are going to introduce it into practical settings. But for now, I think that we need still to do a lot of basic research to have technology that could be in long term used in practical context at all. So for example, think about the task of linking the review and the paper. So it's an extremely hard task. And typically the agreement of humans on this task is very, very low, even if the task is simplified to sentence linking, right? So there's a lot of really groundwork that needs to be done in order to introduce such steps in practice, maybe in very long term.
Hey, Shadi.
Thank you, Irina, for the talk. Great work. Regarding the steps that you mentioned for the documents, I'm very curious about the second one, which is looking at the structure and mainly the evidence tracking. Are we talking about the document will be changing over time and the data that will be used for this is the peer review?
So in scientific domain, yes, but we are also looking at other domains. So for example, in legal domain, you also have living documents, and very often they cross-link to other documents. So I think this problem is actually very common. So think about the software engineering domain. You have code and you have comments and various, I don't know, Stack Overflow discussions. So on an abstract level, you really find it almost everywhere, because we as humans read and write documents in context. So same for medical domain or religious texts. So it's pretty broad, I think, in the application, but the data is crucially lacking for addressing this scenario. And the scientific domain is very suitable to start with, because it's easier to obtain documents which are more or less in the public domain.
Yeah, I think it's a great start on the scientific domain, but I think based on the domain, it will be different. Because with the evidence tracking, if looking at a document that there is some kinds of action that's changing over time, legal would be a good example, or medical, because something changes, then the maybe more knowledge representation as well, in addition to the document structure, can be very helpful to extract the data. Within the peer review, the paper itself will be the same most of the time, but so the views will be changing. So I think knowing the domain also will be important for the extraction that we're looking for.
Yeah, so we are definitely looking to provide different domains, and among them, so there are some freely available legal data sets, Wikipedia, of course, linked to news articles, and scientific domain, but maybe more, depending if we can figure out the legal constraints, copyright, and so on.
Thank you.
Okay, Zerak, please.
Okay. Can you? Okay, yeah, fine. Okay, so I'm a little bit concerned about the idea. Oh, I'm over here, way back.
Oh, you're there. Sorry.
I'm a little bit concerned about the notion of a writing assistant, of a review writing assistant, because one thing is different types of paper require different types of reviewing, right? And so I think the scientific inquiry into how different reviews are written and how, like, is really, really important. And I'm wondering why you're considering writing assistants rather than picking up on, like, here are the specific areas where we see reviews not being that good, and we need to facilitate better review writing through training and so on.
Yeah, but what you describe is what I conceptualize as writing assistance. So pointing out to problematic places, like giving feedback to the person writing a review.
Oh, I meant like, as in having workshops for junior scholars or for junior reviewers to be like, this is what a good review looks like for this type of thing. This is what a bad review looks like for this type of thing. We've noticed that review quality for, let's say, scholarly document processing has fallen over the past for this last conference. So let's address this now.
Yeah, so what's the question? Sorry, I didn't get
So
it.
I'm just wondering why the writing systems rather than, like, why the technological intervention?
Oh, I see. Yeah, so I think this is not either or, but it's rather like providing training and assistance in order to practice that. I mean, it's a writing skill. It needs to be practiced a lot. And, you know, there's huge body of research in educational psychology. People need feedback, but it's not clear who can provide that feedback, because it's a huge job due to the demographic properties of our community. So the idea here is just to facilitate providing constructive feedback so people can learn better.
Thank you.
You're welcome.
Hi, thank you, Irina, for the talk. My name is Tarek, and my question is on if you train such a system on all these papers, aren't you somehow discouraging creative works in the future? So if some paper looks very different from all previous papers, but it's quite good, then the reviewer system may provide negative review kind of.
Yeah, I think that relates to the previous question. So it's not like we mean to replace the reviewing, but we provide an additional tool. But the education of reviewers and their training are the primary goal. And of course, we need to educate people about the potential biases of the technology, so they use that and not just blindly rely on such systems. And as I said, it's not meant as an end-to-end system, but it's meant to, in specific scenarios, to facilitate particular laborious steps, but I do not envisage this to write the review collaboratively with the scientist.
Okay, let's thank the speaker again. And we are behind schedule. We can have now 20 minutes break, coffee break, and let's come back here at 3:20.
Yeah, and also sort of look dependency.
Can I switch with you? Because I want to keep the blue was always with you, and this is for the questions. Just, you know, turn it off and on whenever you need it. Okay. This is on? Yeah.
Hey. Ready to start? Okay, yeah. Okay, so welcome everybody to the last fourth session. Actually, not really the last because we have a panel after that. But the fourth session of presentations, and we have two interesting talks here. So the first one is by Ji Yang from Stanford. Please.
Hello. Hi. It's working. Okay. Hello, everyone. I hope you enjoyed the coffee break. And then in the last session, I'm going to talk about something a little bit different compared to what has been debating today, called socially aware natural language processing. There was this very thought-provoking question for this workshop. For natural language processing, where we are at, where should we be, and how should we get there? You know, the default these days is ChatGPT for. Okay, here is what it generates. Currently, NLP is a rapidly developing field that has made significant progress in recent years. Still room for improvement. I highlight a few that seem very relevant to what I'm doing, and that means something. Okay, understand the complexity of human language. Additionally, there will need to be a greater focus on making NLP systems more widely accessible and user-friendly so that they can be used by a wider range of people and organizations. This also aligns a little bit with what Ed Hovey mentioned for the big directions of human-computer interaction. So I feel very calmed down at this moment. I do not need to talk about this figure. This is not enumerative, only a subset. We know that NLP has entered this new age, whether we like it or not. Despite those tremendous progress we are seeing these days, there are still a lot of arising issues reported with current deep models. As we can see, culture, hate speech, bias, those issues really hinder the practical adoption of those systems. And even with ChatGPT, the login page shows that may occasionally generate incorrect information, may produce harmful instructions or biased content. It seems still very challenging, even for a state-of-the-art model today. So I want to think about this. For all the specific phenomena we see so far around low resource language, bias, hate speech, limited social understanding, the generalized issues are actually about the lack of awareness towards underrepresented groups, culture, ideology, social norm, and the social context. Taken all together, the common theme is what I call social awareness. Social awareness, I think, compared to named entity recognition, dependency parsing, this is underrated today because it's really hard to capture. However, it's very essential and necessary to be well studied as one potential direction for the NLP future. Okay, so my research is to think about how we could incorporate the social awareness into NLP. So if you think about, we have linguistic and the computation for NLP systems, and it's working very well. However, it ignored the fact that language is used by people to achieve different communicative goals. It's people with diverse social background who produce and consume language. If we ignore people, ignore who says the sentence in what context, we are going to ignore the possibilities we could have as a field. So this is my research, very socially aware NLP. I also want to give a formal definition here of what I mean by socially aware NLP. So here, I call it the study and the development of language technologies from a social perspective. Let's first look at the process of what we call classic NLP pipeline. Typically, we have some task inspired by linguistic knowledge, and then we build and evaluate models for this task. So for socially aware NLP, there are this set of social factors from social science, social psychology that we could incorporate into this pipeline. Specifically, social factors can inspire socially informed task, new task. Additionally, social knowledge can be used to enrich representation learning in those models. With such integration, we could produce social impact, which is not only about the typical task evaluation, but also about its impact on people. So now you may wonder, okay, what are social factors? They seem vague. To define social factors, let's first look at some theories in linguistics and social science. So there are systemic functional linguistics, there are cooperative principle, and also a lot of social science theories around the interaction, communication, language interaction. Built on those theories, my collaborator, Dirk Covey, and I, we proposed a set of organized and practical, easy to use social factors that could enable NLP systems with social awareness. As I mentioned, this provides a very easy to use taxonomy on different social factors in language, including who is the speaker, who is the receiver, what's their social relation, in what context, guided by what type of norm, value, culture, or ideology, and for what kind of community goals. To give you an example, social relation, we are familiar with it. It refers to the relation between the speaker and the receiver of a message, such as friendship, seniority, competitor, etc. Like in this utterance, if used between friends, it might be banter. If used between strangers on the street, it might be a threat. Social norm is also not new to us. So if we think about this specific sentence, slurping and making noise while eating, depending on the specific context, it might be perceived as polite, respect, or rude. So we really need this context to understand norms and values. And this turns out to be a big challenge for our ChatGPT and a lot of these value alignment systems. Another example is context. Context is what I understand as a container where language interaction happens. It could be the domain, could be the language topic. Like in this example, that was a sick performance. Depending on the specific context, it may have different meanings. So now we know what the social factors to consider for socially aware NLP. Why is this hard and what are some fundamental challenges? There are a lot of them. So here I summarized 3 prioritized challenges. The first one is how could we formulate those socially informed tasks and create resources that can reflect user needs. The second aspect is how to design models specific to socially informed task by incorporating those social factors for richer representation. The third is that if we take into account the different social factors and the socially aware design, how could we build or make a real world impact with responsibility out of our NLP systems? So I'm not going to talk too much about all the challenges. And instead, I want to share 3 recent work that touch on those social dimensions to give you an idea of what a socially aware NLP means. So the first part, I want to talk about how we formulate a task informed by social factors. And this is a recent work done by my students on culture and dialect use with the goal of building dialect inclusive natural language processing. So as we all know that all natural language follow a systematic set of rules, and all natural language experience variations. It could be from different regions, etc. As a result, there comes with dialect, which is defined as a group of systematic variations in a language. I do not need to emphasize this more, but we saw that existing language technologies struggle with dialect recognition, dialect-related tasks. So as you can see, for this linguistic prejudice, it has been shown in speech recognition systems, in hate speech detection system, etc. So those are all the real issues that NLP need to solve, and it could affect many end users. So why is dialect hard for today's NLP? So if we take English as a case study, which we think that we already have a lot of resources. Here, I want to mention that inclusion requires curation beyond the standard American English, and a lot of those dialect data got filtered out during the pre-training process as low quality. And if you simply combine those, it often harms performance. So to kind of mitigate this potential disparity between dialects, my group has been building this effort called value. The goal here is that how could we build a dialect-specific stress test? How could we create a reliable benchmark that reflect language use? And how could we develop plug-and-play open tools to facilitate future research? So far, we have been working with a set of English dialects, including African-American vernacular English, Chicano English, Indian English, Singapore English, multiple of them. So the goal is that to create synthetic morphosyntax transformations covering known or pervasive syntactic variations of around 50 dialects. So this type of approach is actually very beneficial for multiple reasons. First, this is not a black box, because we can easily source transformations to specific feature rules and trace their effects. We can interpret the impact of specific linguistic attributes and structures on model performance. Second, it's very flexible. Since we are going to do this synthetic transformation, our method is very flexible, as we can easily tune the feature density at a very fine-grained level. It's also very scalable. We can easily transform new data sets and expand our analysis to new NLP tasks as they are released. It's also very responsible. So during specific tasks, we take a participatory design approach from the HCI field with members of, so here for African-American vernacular English, we actually work with Black community in Atlanta to incorporate the interest and the feedback of stakeholders in the construction process. So to give you a quick glance of how that works, we take sentences from standard American English and then perform morphosyntax and a lexicon translation based on linguistic knowledge. And then we end up with something synthetic in the middle. We then work with native speakers to validate and rewrite them into something in their dialect format. So through this process, we can create stress test examples. By combining both linguistic knowledge and the speaker input, we hope that this line of value could be made in a way that's both linguistically profound and also socially accessible by their speakers. Finally, our approach is generalizable. So we can actually work on many dialects, many tasks at one time. To give you, again, a quick example here. So if we take any big models, this here I use Roberta sentiment analysis data set. As we can see, if we have models trained on standard American English and use them on value stress test, we see that the performance drop. And actually the drops for almost every data set in the glue benchmark. And then for daily interaction tasks, such as question answering, if we do transformation to the questions, we see a much bigger drop here. And if you just fine tune on this dialect data, it actually didn't help a lot. The other goal under this value effort is that we want to achieve this adapting models trained on standard American English to other English varieties. So here, the key idea is to develop task agnostic dialect adaptation, which we also call TADA here. And then also use composable techniques to improve robustness across tasks without a retraining. To give you a quick example of how we achieve this, we also mentioned like dialect and the prompts today during earlier talks. So here we actually leverage this type of prompt tuning where we design this yellow prompt here as VP, like a different type of virtual prompt to capture dialect specific information. And then the big model is frozen during the learning process. We only learn these different dialect representations specific to a given dialect. As we can see, compared to just this kind of Roberta, having this dialect adaptation improve the model performance, even only using a very, very small amount of parameter size here. And such improvement is consistent across other global data sets, but also across Squad and many others we have been experimenting with. So the final goal, which we hope to release later this month, is for these value transformation sets that work for more than 5 dialects. We also have this goal, the value benchmark, which we will release on Hugging Face together with all these pre-trained value models. So that's the first part. The second part, okay, there is an I missing here. It's about interacting with socially aware models. Interaction is something that I feel very important, especially given all these kind of prompting techniques. And it also goes to something related to all the objectives we have been talking about. So on the left, I have a lot of what we call very classic objectives for NLP systems, where we have accuracy, performance, we have efficiency, we may have out-of-domain generalization, etc. On the other side, I have a few keywords that's very important when I think about the social awareness here. We have usability, we have engagement, we have interaction here. If we apply NLP algorithm to all these kind of socially aware tasks, here are the key challenges. We have unseen data. Sometimes we need to make it adaptive to users and the context. We need to provide explanations. We want to know who to hold accountable when there is any errors happening. There are unpredictable model behaviors as well. From the other direction, if I think about a lot of those socially aware or socially innovative tasks, sometimes it's really hard to articulate what can be done by current systems or what cannot be done by current systems. There are also this kind of technical feasibility we have been talking about. There might be prototype challenge because in design or in this kind of HCI, it's so easy to kind of come up with one specific design, but we want to test how well it works. This is always a very long cycle. There might be open-ended feedback from this social domain that we may not know how to incorporate into the model design. To kind of experiment this or to think about this further, I have been working on hate speech detection for some time. And I was thinking about this black box model from an end user perspective. So for people who are making posts online, moderation means that if you have an input, it might be associated with the output of whether your post is delayed or not. So could we make this process more transparent for end users? To kind of work on this, instead of building more accurate classifier, which we have been doing for detecting hate speech target, all sorts of things, we did a design here. That is, we invited people who have experience with online toxicity to help us think about how to design a system. So here, we actually designed an interactive tool called the Recast. So based on user feedback, we make it very interpretable. That is, we provide explanations of comment removal. We also kind of make the interface very minimum to kind of ensure those visualizations are not overwhelming. We provide recourse and feedback. We make it accessible, etc. Here is how the system looked like. It was a web plugin. When you input a specific message, we highlight which words might be potentially problematic, which phrase might be problematic based on all this kind of attention gradient-based interpretation. And then we also suggest potential words to use. So far, it works very well. And when we run different type of user evaluation, such as giving a short video about this system and ask people to follow this, to write something, or to comment on a news article, etc. We found that people like this system. Over 70% users agree that this system help reduce toxicity, and around 80% people think recast help them understand how toxicity detection works. This looks great. However, if we look at the potential toxicity in those rewrite content, we found that although the toxicity as detected through models are reduced, if you look at this real toxicity provided by a third-party annotators, it actually has slight increase here. So what comes or what happens is that people game with the system. They write more toxic behaviors that bypass current tools. They write it in a way that's so implicit that's really hard to detect given the context there. As a follow-up of those, we actually work on this implicit hate speech. That is, we look at all this hateful content without using any explicit keywords, such as this irony or sarcasm for hate speech, or incitement where you don't use any of the words there, etc. So from this work, I really get into this interactive nature of NLP systems. That is, if we could make the systems interactive, maybe we could learn from such interaction to better improve the models, to better improve the data set, to better improve the dissemination of such systems. This idea is not new. So if you look at a lot of the adversary data generation, there was actually an earlier work that visualized what's happening in the system, and then users rewrite it based on those visualizations to create a more adversary QA examples here. You can also use it in a good way. For example, there is a recent work called co-author where human and AI collaborate to write something together. And it was demonstrated that with this collaboration paradigm, we actually have more diverse, more, I guess, higher quality content here. Again, this designing, evaluating, or learning from interactions is something that you also see a lot with current ChatGPT or all sorts of models. I'm running this workshop on story shared and lesson learned at EMLP. Yesterday, when I was trying to advertise this on Twitter, I asked GP3, actually ChatGPT, giving this content. So I pasted the first paragraph of my workshop. Please write a tweet to call for participation in an Elon Musk tone. So as you can see, it's actually very, very impressive. Attention, all NLP rebels and inventors, join us at the workshop and help us push the boundary of human language understanding. Share your bold ideas and breakthroughs, and let's change the world together. So very, very nice. So the backend is actually, as we read from their blog, is this kind of learning from human preference reinforcement learning paradigm. So this kind of interactive nature, to me, seems to be a very cool directions to pursue. In the last part, I'm going to talk about something that I also think is going to be a key dimension, that is more around the translational impact. How could we support language interaction in key domains? One of the work I did is to take all the fancy NLP techniques that I have learned to see how could we go into the real world. And actually, my experience in this direction revealed that if we put NLP into the real world context, we get to know more about the power of language and how much benefits it could produce for the outside world. So one thing we did is we collaborated with American Cancer Society. They have this website called the Cancer Survivor Network. we got access to a really huge data dump for many years. And then what we did is we look at the language people use there. We identify emotional support, informational support, all sorts of exchanges people made on the website, and then identify what are their specific social roles, like revealed by their language. So we have people who provide emotional support, people who are newcomer welcomers, people who share stories, people who are knowledge promoters, etc. We then kind of leverage those social roles we learned to better support the patient communication, where we match people based on the content, based on like whether they are looking for emotional support with appropriate caregivers, etc. We deployed the system on the left side of CSN. So when a user logs in, they will see the thread we recommended to them based on their needs, based on their posting histories, as well as the people expert, caregivers, informational expert we match them with. So during the 1 year intervention time period, we have over 11,000 people who signed up, used this intervention. And we see that this type of content-based recommendation based on their support provision history increase people's reading. So now this kind of direction still excites me a lot. That is, giving all these kind of large pre-trained models, how could we use them for something more translational? So here I pick the skill training as one example. That is, given the powerful potential of those big models, how could we allow users to experiment with different situations simulated by those big models? And how could we provide on-demand feedback to improve conversation skill? So one of such skill is what we call thinking skill. The goal here is that how could we help people achieve positive benefits induced by language? We call this positive reframing. Okay, let's just take an example here. Let's say many of us have this issue. I absolutely hate making decisions. I found myself having a lot of those to make. We have style transfer. Here's what a style transfer will give you. I absolutely love making decisions. I found myself having a lot of those to make. You won't be supported by this message because it kind of provide this contradiction here going on. We could do better than style transfer. So in the positive reframing part, we kind of rewrite in a way that we maintain the semantic equivalence, but shift the focus from something negative to something more positive. So here I have a lot of decisions to make. It'll become easier once I start to get used to it. Then you can actually leverage either GPT-2 or GPT-3 to do this kind of automatic reframing. We have something like, it's such a holiday, get converted into this hot weather, make it perfect for ice cream. It actually goes beyond this. We utilize it in the context of counseling, which I'm going to talk about right now. Before that, I want to mention that although the system was working perfectly on the training data or on the test set, you still see this very superficial or shortcut as we observed. For example, there is this like all fits all, one fits all sentence like, but I'm strong and I know I can handle it to every rewrite we encountered. As I mentioned, so now we are using similar technique to kind of help therapy skill training here. As we all know that under treatment of mental health remain a key issue, and then peer-to-peer counseling seems to be a good alternative. But the training therapist or training supporters, even every of us, could be very costly, and traditional approach cannot scale. So what we did is we look at all sorts of counseling conversations and try to understand what are the counseling strategies experts use. So we based on this framework from psychotherapy called the motivational interviewing strategies. As we can see, there are many of them. We continue fine-tuning large language models to the context of mental health. As we can see, this type of continue fine-tuning actually improve the performance a lot. Not only in terms of performance improvement, we are trying to leverage those strategies to better help people, especially beginner therapists, at a skill in their training environment. So basically what we are doing right now is we are generating feedback to help people navigate or deal with current situations. So this is all in a simulated environment, which means that before people talking to real patients, they will practice their skill in this simulated environment where we give feedback. We give feedback at different levels or assistance. First, diagnose which skill to use, like here, show empathy. We provide suggestions, like try to be supportive and show understanding. We also highlight example response that people could use, such as sounds like you are going through a challenging time. So we provide a different level of assistance in the process of training. And here is a demo. I heard that a live demo never works, so let's see. Okay, so this is the current interface. So basically for a message having from the member side, the counselor will see this kind of recommendation from our system. This is actually generated on the fly. So we can see there are support, close the question they can use. And whenever they click something, they can also edit that. This is actually running right now, and our first stage user interview and with domain expert show that people like this type of interaction, and it's actually working very well. After we remove a lot of or deal with a lot of ethical considerations. Okay, so that's what I want to share here. So how could we formulate a task informed by social factors, interacting with socially aware models, and then use those socially aware models for translational impact? I'm very excited about this socially aware NLP direction. And to me, I feel like it serves a bridge for many purposes. First, it creates a bridge between task and people. So we could have more human-centered NLP tasks informed by social factors that we can use. Second, it serves as a bridge between those model and the social interaction. So we can actually integrate the social factors into those model design for enriched representation. I don't have a great solution, but this is at least one direction to think about. And then the last part is how could we bridge the evaluation, the real world impact divide, which I call here. That is, how could we conduct translational work in socially aware NLP with responsibility for social impact? And to kind of answer the question of where is the future of NLP, from a personal perspective, I think in the future, we hope the NLP systems could be more socially aware, be aware of all the social factors, and be more interactive, so we can actually interacting with it, even we are not NLP experts, and also kind of be more translational, adapting to different domains and produce real world impact. With that, thank you and happy to take questions.
Questions? Yes.
Yes, hi. Thank you very much for this very insightful presentation. I just have a quick question regarding your hate speech model. So how does it go about detecting sentences that have low toxicity, or classifying sentences that have low toxicity, but that are inherently sexist? For example, let's say benevolent sexism. So I'm surprised at how smart you are for a girl. This is like has a positive connotation, but is underlying a sexist or a hate speech sentence. This is the first question. The second question, referencing Professor Barbara's presentation. So hate speech is like, to me, maybe a large umbrella that encompasses a lot of linguistic theories. Couldn't categorizing the various forms of hate speech into the even subtypes of benevolent sexism, hostile sexism, in a way decrease the inter-rater disagreement? So when you have a large umbrella such as a hate speech in general, one might look at the sentence I just said and say that, no, that's positive, that might not be. But if you have a very clear guideline of the various types, it might decrease the subjectivity or disagreement. So thank you.
Yeah, thank you. That's an excellent question. So for your first question, like a microaggression or this kind of stereotype in a very subtle way, that's exactly the reason why we want to create that interactive system. Because actually for many users, we use language without realizing the potential impact it might have on others. That's why we see this task is very subjective. So in the interactive system we designed, you can actually plug in any type of detection system. So here, I only use toxicity detection as a way to show how you could actually make it work in this interactive fashion and then design like rigorous user studies to study that. But you can actually plug it with this microaggression. There was a great paper from Julia at UW where they define microaggression, which you can actually utilize it in a similar way, because all the interpretability work we leverage off-the-shelf interpretation and then visualize it through that interface. So we can actually visualize those very subtle things. So we have this kind of very game effect we have, but without that, the original goal was to kind of implement that as a web plugin. So think about people on Reddit, they could see these potential highlights just like Grammarly and then be more aware of their language use. And then for your second question, so yes, you are right. So hate speech is a giant umbrella. I don't think we solve the space. The implicit hate speech actually is what I think a great dimension, or I guess a very different dimension into that space. Because if you look at a lot of the research, we look at the racial identifier, we look at explicit swear words use, but there are actually this bigger scope of we actually don't use those and people can still make a hateful comment. So, and those are very dangerous speech I listed, such as incitement of violence, that type of thing. No matter the background or whatever, I think it's still that's like what I think the category that should have very, very high grade. With regard to like relative subjective categories, I totally agree with whatever I mentioned this morning, that we need to really understand annotators, having their annotations, understand their disagreements, and consider what we mean when we make a prediction.
That makes a lot of sense. Thanks a lot.
Thank you.
Other questions? Yes, Magna.
Hi, it was a very nice presentation, very nice talk. Thank you. So I had a question. Can you please go back to the slide where you were talking about style transfer?
Okay.
Yeah. So what I understood by this, like you are just trying to change the hateful word. Is it so? Or you are trying to formalize it? So what is it here in this particular slide?
Yeah, so this is a new task, which we want to help people express their thoughts in a very positive way. So we call this task positive reframing. So the idea is that if you have something negative, we want to frame it in a positive way, but keep the semantic equivalence of the event you are talking about. And this is something that the current system can't deal with. So if you have style transfer, it only changes the words into opposite meaning. So you end up with something that reads positive, but also it change this user's original attitude towards it. Versus in this version we provide, we actually maintain the same event, but try to shift the focus from the negative side to positive side. So I didn't mention a lot about the implication here, but we're also working with people in education domain where they use similar technique to help teachers reframe their language into more supportive when interacting with kids, like during elementary school.
Is it similar to hate normalization?
This work has not much connection to hate speech.
Oh, all right. So follow-up question with this is, have you also tried this with implicit hate speech? Like I have seen hate normalization with explicit hate basically. So it is much easier. But when we talk about implicit hate, it is difficult to identify the particular span and then change it. So what is your say on it, on like how can we do that in future?
Yep. I didn't present it, but in the original implicit hate paper, we also talk about how could we explain the prediction there. So we basically produce a generation of the implicature of that language, and then you can also leverage interpretability technique to visualize the potential strain, etc. So we actually have more experiments in the original paper.
Okay, all right, thank you.
Okay, Zirak.
Katie, okay, this is sort of a big question, so I don't know if I'm expecting a good answer to it. You present a couple of tasks that are potentially questionable to reframe in, right? So hate speech is one where it's like, well, like you see, people game your system to become more creative in how they're hateful. But let's say that people don't do that. Let's say that the system works. People say, yes, we will accept these rewrites as to make it less toxic, but imagine it's a fascist who's doing that, right? So they make their language more palatable. There are some limits to when we should be helping people, right? And when we should have the systems be interactive. And where do you think those limits are, and how do you think we need to address that?
Yeah, that's also a great question. So when we design the system, we actually think more than what I present today. We think about what could go wrong with this potential system, especially for social domain. A lot of the system we design, they are used by end users who are directly affected by that. So in those scenarios, we really need to think about what if the research leaves the lab, what could go wrong, what are some mitigation plans, etc. So that's the philosophy we actually follow for each of the work I mentioned here. So with regard to that interactive visualization system, several dimensions. First is that we actually give people like full disclosure of how this kind of system work. We have this kind of consent where we hope they can use this in a more beneficial way. So think about how this could help you with uncertainties, etc. We also have the potential log of when people kind of interacting with the system. We want to kind of potentially audit what's happening there to see what the potential problematic behavior might demonstrate in that process if they use it in a bad way. Okay, those are more from the mitigation perspective. The other thing is whether we should help people with this type of task. So think about moderation. Moderation today is done automatically. For a lot of end users, the content gets removed without any explanation. From their side, it's very helpful so that they can get some interpretation of what's happening. And that was actually the need finding. I didn't present in my talk, but we actually have the pre-stage where we talk to a lot of people to figure out what do they really need, and their needs driven the system design. So it's actually after a balance of the benefits we could gain from the system and then the potential risk. So a lot of those is not a binary answer of, okay, we should do it or we shouldn't do it. It's more about how can we do it in a relative responsible way after taking into account so many different privacy ethical considerations.
Yeah, very quick question.
Thank you. Thank you for the presentation and great work. Regarding the hate speech, we mentioned that there's multiple types of bias, sexism, and racism. What are thoughts about the evaluation methods? So right now, the evaluation method do not consider bias or demise model, right? And it just get the results, and it does not consider the biasing. So it's not reflected on the evaluation measure. What do you think that should be done to mitigate this gap?
Yeah, that's also a great question. So in terms of hate speech, in terms of other type of systems, we see these bias issues. And that's actually one of the reasons why we really want to have more work in this kind of socially aware direction, because we really need to understand the context. Who is the user there? Who is the receiver there? And what's their social relation? So think about use toxicity as an example here. You need to understand the context to make a fair prediction. The example I showed to you earlier in the presentation where we talk about social relations. So a potential problematic sentence might not be okay if used between close friends, and shouldn't be okay if used in other contexts. So as you can see, there are a lot of contextualized factors we really need to consider. And this kind of social factors provide a potential lens in terms of how we could better understand the context in order to have more comprehensive and a fair understanding of the space. The other thing is that you could also use those social factors as a way to visualize or audit existing models. For example, for a model, could we break it down when it comes to evaluation metric across different groups, across different kind of dialects, etc. So yeah, I think it's a great question.
Thank you.
Okay, let's thank the speaker again. And now we are moving to our WASP speaker, Mohit Bansal, who is actually going to be online. And, he's going to connect over Zoom.
Hi, yeah, I'm already there. Can you hear me? Hello? Hello?
Yes, we hear you. Can you hear us?
Yeah, can you hear me?
Yes, yes.
Okay,
We don't see you yet on the big screen. Just
yeah, it was
wait a
saying,
second.
it was telling me not allowed to, the host has disallowed video sharing. Let me try again. Yeah, it says unable to start your video because the host has stopped it.
Okay, we are, yeah, we see your slides here on the laptop. Kind of, we are just now. Okay, so we see them on the big screen as well.
Thank you for waiting patiently, Mohit, online. Sorry, we've been running a little bit late. I realize it's early in the morning for you.
No worries, no worries. Yeah, gave me some time to settle down.
Yeah, yeah. So you see your screen, you are not in full screen mode, but.
Yeah, that I was going to do, but I was waiting for the video permission.
Okay, yes. So you are all set. Whenever you want, you can start.
Okay, so should I skip the video? It still doesn't allow me to share my video.
Your video?
Yeah, I mean, you don't need to see me, I guess. I'm just saying I can show my face, but it's not allowing me, so I can just.
You cannot see yourself. Okay.
But that's fine. I mean, if it's tricky.
Okay.
Go ahead, Mohit, and when you finish your presentation, we do the Q&A. We can, you can stop screen sharing.
Awesome.
We see your beautiful face.
Yep. Okay. Yeah, just go ahead.
It's the morning anyway. Great. So I think you can see full screen now.
Yes, we do.
Okay, awesome. Great. So yeah, thanks for having me virtually. Sorry I couldn't be there. I'm enjoying childcare right now, but hope to see all of you at the next conference soon. So yeah, so I'll be the last talk of the day. It's around 7 a.m. here. So, and if you hear any sort of baby noises in the background, please excuse that in advance. So I'll talk about unified and efficient vision and language modeling today. This will be sort of like a short 30-minute journey on basically taking these very large scale pre-trained language models that surround us these days and look at how we should be also discussing their multimodal grounded versions into images, audio, video, etc. So I'll be giving sort of a short journey of like from the very first large-scale cross-modal pre-training model, and how so many thousands of these have like popped up in the last maybe 5 years. And so hence also focusing on how to improve their unification, generalization, and also efficiency, because they are becoming, especially with vision and language, these models are trillions of parameters soon. So big focus needed is on the efficiency of these models in terms of parameters that need to be updated, memory, storage, and so on. So, so this is a visual version of the talk outline. So in the first part of the talk, as I mentioned, I'll show one of the early cross-modal pre-training models, where basically how do you extend something like BERT to be able to have a language stream and a vision stream and a cross-modal pre-training setup with different kinds of cross-modal pre-training tasks. Then in the second part, as I mentioned, there's several of these V+L models. So this is going to be one of the first examples of how we can unify V+L, different kinds of vision and language tasks that look very different on the surface, and treat all of them in a unified system, maybe as, for example, in this case, conditional multimodal language modeling, language generation. And then we'll switch gears a little bit and look at how we can improve language-only tasks, text-only tasks, by grounding them into image and video through knowledge distillation. And then the last part, we'll discuss efficiency, as I mentioned. So let's get into the first brief sort of part on one of the early examples of cross-modal pre-training. So the background here is that several years ago, this whole sort of pre-training and fine-tuning motivation that we are surrounded by now is that basically the motivation was that there's much limited amount of data in downstream tasks where you need specific complicated annotations, but pre-training data, which is sort of, you can think of it as self-supervision or natural supervision or existing naturally existing supervision, there's much more of that kind of data. So in the vision world, in computer vision, this kind of pre-training and fine-tuning pipeline looked like taking, say, millions of images in a corpus like ImageNet, and then doing image classification for pre-training, and then fine-tuning on smaller data sets like MS COCO for more downstream tasks. Then on the language side, you would do something similar where you could take all of Wikipedia and do sort of a masked language modeling, fill in the blank kind of task for a pre-trained language model using architectures like transformers or anything else. And then you could do fine-tuning on smaller data sets, for example, on movie review data sets for a downstream task like sentiment analysis. So now this is all great for fine-tuning on single modality tasks, right? But what if you have tasks where you want both vision and language information? Now, if you have these parallel sort of pipelines of vision pre-training and fine-tuning, and then language pre-training, fine-tuning, the problem is these single modal pre-trained models are not going to be aware of the interactions that are needed between the vision and language. So one early thing that you would have tried would be multimodal fusion layers, where you would just do something like late fusion on the layers and parameters of these vision and language pre-trained models. And then you would apply these to your downstream tasks like visual question answering, navigation, grounding, etc. But as I mentioned, the problem is that they will not be aware of the interactions right at an early stage. So that's what LexMert and Wilbert, some of the first cross-modal pre-training models, almost, I guess this started 4 years ago now. So this is basically the simple idea of how to build a pre-training system that has early interactions between the language and vision side, and also joint pre-training objectives across the modalities. So in this case, LexMert, as mentioned shown on the slide, it basically has this bottom side, if you can see my pointer, of the language pipeline in terms of masked language modeling. And then on the top, it has a similar version for the vision pipeline, where instead of masking words, you're masking regions inside an image. And then you can basically do region of interest features or positional features, and you get an object relational encoder, just like our language encoder. And then these both sort of interact inside a cross-modality encoder, which could be two streams or single stream concatenated. And the basic idea is that you have these three encoders then, object relations, language, and cross-modal. And then the more interesting part is the 5 pre-training tasks that you bring in. And these can be many other different kinds of pre-training tasks, but you want something like the language side pre-training task of masked language modeling, and the vision side would be masked object prediction. which again can be both at the feature regression level or the label classification level. And then you would also have things like cross-modality matching, like given image and caption pairs, the model has to predict true or false, whether they match or not, or question answering on images and so on. So you basically have these 3 different types of encoders, and the pre-training tasks also are accustomed to make sure that they're also talking across the 2 modalities and forcing the model to do tasks that need both modalities information. So again, this was, I'll not go too much into the results of like this older work, but the idea was that back then this was a big jump in terms of all kinds of multimodal tasks like NLVR, which is multi-image class entailment. Okay, I can start my video now. Okay, now you can see the darkness of the early morning here. So this is basically visual question answering. NLVR, VizViz is a particularly interesting task where these are not standard sort of complete clean images. These are images uploaded by people with visual disabilities. So it could be out of focus, out of frame, incomplete images. And so these are some of the different kinds of multimodal tasks that these cross-modal models gave very big jumps on, similar to what we saw when the first big language models came out. So then the problem that happened is since then, I mean, there's probably 700-800 different kinds of these vision language pre-training models. And they can differ in terms of the architecture that they use, or the pre-training objectives, or the data sets that they use. So this sort of naturally goes into the second part of the talk, where how do we start thinking about unifying these very different kinds of vision and language pre-training models to treat them as one single system. So this is what we did in VLT5 at ICML 21. So the idea here was that if you have these diverse vision and language tasks, let's look at the left top, which is visual question answering. It comes with an image and a question, and then the model has to generate an answer. And this could be one of the top 1,000 answers in a multi-class classification setup. Visual grounding is very different, where you're given an image and a referring expression, and the model has to ground and find the bounding box or the segmentation of the part of the image or the region of the image that is being referred to by this referring expression. Image captioning would be, again, image generating a caption, and then multimodal machine translation is yet another very different looking task, where you would be given one language and an image, and you have to generate the same information in another language using the image as a bridge. So in terms of task-specific architectures or objectives, the problem was that all of these tasks were being handled through very different architectures. So basically, in this case, you will see that on the left side for visual question answering, you would basically have the image features, the CLS token with the question features, and then some kind of VNL transformer, which could be single stream, multi-stream, different kinds of attention mechanisms. Then the VQA head, and there'll be a sigmoid that basically scores the top K answers. Like visual question answering setups usually come with 1,000 answer categories. So this would become a multi-level classification. Whereas if you wanted to do something like visual grounding or referring expression comprehension, you would have something like the image features, again, the referring expression fire hydrant, maybe a completely different transformer that is accustomed and very specialized to get the best state of the art on this task. And then it would also have different kinds of attention mechanisms and single stream versus multi-stream, different pre-training objectives. And then it would also end with something different than the left side. It would more have focus on getting region scoring heads and doing a softmax for scoring different regions in terms of the bounding boxes, and then finding the highest scoring region. So the question we asked in BLT5 is, can we tackle all these very different looking vision and language tasks with a single objective? And so we did that by treating all these tasks as text generation. So what does that mean? For example, if you are thinking of getting this image and the task is about multimodal language modeling, that just means multimodal fill in the blanks, right? So X is Y over fire hydrant, man is jumping over fire hydrant. So this, in this case, this can be the text generation output. If you're doing visual question answering, then it's pretty natural. Instead of classifying the answer from 1,000 answers, you could try to generate the answer piece by piece. Visual grounding is more interesting, where instead of generating, scoring the bounding boxes for a referring expression like yellow fire hydrant, you can actually try to generate the ID of the box also as text. And then something like image text translation, image text matching is also natural because you will generate false versus true for whether this text and image match each other as opposed to classifying true versus false. And then the other tasks also hopefully make natural sense. So like multimodal machine translation, you will also be generating the other language as text generation. Image captioning is pretty natural as text generation. So that was the basic idea. This is the summary of VLT5. So you would basically have the name of the task as the task prefix, and then you would have the text input, in this case, the referring expression fire hydrant. You would get all the visual features as input. So then you would basically feed all of this in as a single stream bidirectional multimodal encoder. And then there would be an autoregressive text decoder on the output side that in this case, for example, for this task, its job is to generate the ID of the bounding box. And then for other tasks, it would generate either the answer or the caption or the multimodal translation and so on. So basically all the tasks are getting treated as multimodal conditional language modeling. So again, just to recap, this is what the previous sort of specialized models would look like. And the bottom side shows how you can treat all of these as conditional multimodal language generation. So this would again be the task prefix. So this is sort of an earlier version of task prompting, but you would have the image features, the name of the task, the text input, and then everything being generated as output in text. So either a question's answer or a bounding box ID and so on. So again, I think it will be, I'll not go into too much details in terms of this 30-minute talk, but I'll give you some of the high-level takeaways. So the first takeaway was that this sort of joint model like VLT5 can individually match pretty closely, sometimes slightly higher, sometimes slightly lower, but on average can match the performance of individually sort of trained models for each of these tasks. So if you basically give individual training inside VLT5 for each of these tasks, the architecture, it means, can handle all of these tasks close to a similar parameter size model that has individual specialized architectures. But more interestingly, what you can do is you can actually share the parameters. So with 1/7 of the parameters shared inside the single VLT5 training, you can still get comparable performance to the version where each of these columns has a different separately trained model. So 7 times the parameters. And so in general, there's been a lot of very useful follow-up work, like you've probably heard of SymVLM, Flamingo, Unicorn, GPV. So now there's even sort of more advanced versions of unification built on top of this, where you can also do image generation as a joint task, right? So you have multiple decoders that are doing image generation and language generation. And then one other more interesting sort of bonus of this language generation setup for unification is that on rare answer settings, right, where the answer in the visual question answering case is either unseen or rare, the generative setup of VLT5 can handle unseen categories much better, even compared to models like Uniter, which have 16 times more images and data. Okay, so that was sort of the unification part of the talk. Now I'll shift gears a little bit and focus, as I mentioned in the beginning, on giving you some examples of how we can take text-only situations, right? So if we want to take text-only tasks and improve their visual grounding, how should we go about doing that? So this is the idea. Again, if we go back to the motivation of what the pre-training and fine-tuning setup is, I showed that to you here. Right, so you basically have a completely language-based large data set like Wikipedia that you're pre-training your language model on, and then you fine-tune it on a downstream task. So the thing that's missing here, so this is our Vocanization paper from EMNLP 2020. So the thing that seems to be missing in this setup was that visual pointing, right, which is an essential step when we learn meanings of words, is not really being sort of addressed into these large-scale language models. So that was the idea of Vocanization, which is basically visual grounding or visual pointing for language models. So here what we do is we supervise language models with visual grounding, and this is what we call Vocanization, where Vocanization is basically grounding a language model with vocans. And vocans are text to image alignments. So these are, you can think of them as word to image mappings. where the words are in context. And these alignments come from a vocalizer. And in other words, you can also think of it as knowledge distillation from a teacher, which is a vocalizer, to a student language model. So let's see what I mean by vocalization. So this is the basic idea, right? So if you think of the original BERT setup, it's a fill in the blank task where a given sort of, so the masked language modeling objective, right, that you have to, I usually think of it as fill in the blanks, that you are basically given some masks and like missing words, and the model has to figure out what are the missing words. So instead of that, in addition to that, the model is also being asked to map or point visually to these tokens, which are token related images. So that's the job of the vocalizer on how to get these mappings. So the problem here is that something like BERT, right, which is going to be a language model used on language tasks, these kinds of models are trained on Wikipedia style data, right, because these are longer sentences, much longer vocabulary. So it's the kind of data that these models will be trained on and will need in downstream tasks that are applied on. Whereas multimodal data sets like MS COCO captioning on the left side are very different, right? They are much shorter captions, they have much smaller vocabulary, very different kind of grammar and so on. So the idea here is that, so this is, remember, pre-clip era, right? So now we've also, like, you can also do the same thing. We've extended this to like clip versions, but this is sort of, think of it as a smaller version of clip, where the idea is that you first can treat the vocalizer as a model that's trained on a multimodal data set like MS COCO captioning. So its job is to take words in context and be able to learn what image do they map in, right? So once you have that vocalizer, that's an alignment, contextually trained alignment model, you take that vocalizer and then you, so basically that's the left side, you train a vocalizer, a contextual word to image mapper, and you annotate then all of Wikipedia with these mappings. So you can train the vocalizer on MS COCO, and you can ask it to give you all the contextual tokens to vocans mappings for something much larger like Wikipedia. And then you basically retrain BERT with an additional pre-training objective to get visually grounded BERT, right? Which or vocalized BERT. So that's sort of the summary here, right? You train your vocalizer or aligner on MS, something like MS COCO, which can be any like latest data set that you have, or even a model like CLIP. And then you would basically annotate all of something like Wikipedia, which can be replaced again with the best sort of data set that you're using currently to train BERT style models. And then you would basically retrain BERT with this text to image mapping task as an additional pre-training objective. And then you can see whether this helps on text only tasks. So that's sort of the summary, right? The left side would be the original BERT where you were doing masked language modeling, right? So these are masked words like learn and listening, and the model has to predict those. And then you would all in vocalized BERT, you will also have this vocal classification task additionally, where the model is also being asked to map and find the corresponding visual mappings for these words. So on different kinds of glue tasks like SST, QNLI, MNLI, you can check the details in the paper, but this vocalization gives good improvements on these text-only tasks. But before we get into more interesting tasks, let's look at some sort of extensions, right, to vocalization. So in terms of the issues or caveats with vocalization, there are three main issues here, right? So one is quantization error, because finite images that are being used in a vocalizer, these cannot represent diverse enough concepts. And also they're using static images, which cannot represent motion or action. So the idea here was that can we basically move from images to videos to handle this in a better way? And can we also look at more strong distillation objectives from teacher to student transfer as opposed to an alignment-based vocalizer objective? So that's what we did in Biddle and KD at NeurIPS last year, which is video language knowledge distillation. And the idea here is that you pre-train first. So it's a very similar idea, but extended to videos and with better distillation objectives. So again, you would first, you pre-train a cross-modal language model on a video data set. And then you basically take that, so this is the teacher model, and you take its language model. So that's the teacher LM, you freeze its parameters, and then you try to distill its knowledge into a student LM, which is trained only on text data sets. So that's the second thing I just mentioned, right? So you first, so the left side is you pre-train a cross-modal language model on a video data set, and then you transfer this frozen teacher language model's knowledge into a text-only model, which is the student LM using text data sets. So if you go into a little bit of detail, this is the teacher model's training setup. So it has these two kinds of popular pre-training objectives. So the video language contrastive learning is the main objective, where you are given pairs of positive video and captions versus negative video and caption pairs. And you basically do a contrastive learning setup between the teacher visual encoder and the teacher language model. And then the masked language modeling setup is the usual MLM setup. And then on the student side, what you do is, again, I skipped the masked language modeling objective, but the more interesting knowledge distillation objective is the idea that you input the same text with the same masks to the teacher and student model, right? So the teacher language model came from the previous step, right, from this side, and it's frozen now. So you basically keep the teacher language model frozen, which has been trained using video and language data. And now you input the same text with the same masks to this teacher's language model and the student language model. And you basically transfer this knowledge from the teacher model to the student model using different kinds of knowledge distillation objectives. And again, I think I'll be probably out of time soon to go into the details of different objectives, but we go all the way from like mean square error and soft labels in 2014 to very recent, better distillation objectives like contrastive representation distillation. So again, I'll give a brief summary of the main takeaways here without going into too much details, but the main idea is that the first results takeaway is that video vocalization performs better than using images. And then also knowledge distillation objectives perform better than the vocalization objective. And the best knowledge distillation objective is a combination of NST and CRD. More interestingly, if you start zooming into what kinds of knowledge does videos bring in here and what kinds of different text-based tasks get improvements. So we had three sort of more diagnostic-based linguistic and physical temporal reasoning tasks that we looked at. So for glue diagnostics, we found that most of the knowledge comes from the knowledge inside the knowledge subset of glue diagnostics from this Widland-KD video knowledge distillation setup. And then for PICA, where the idea is that you are given, so this is physical common sense based question answering from Yejin's group at UW. So the idea here is that you basically have the context and the hypothesis. Yeah, so the idea is that you have a context like to remove a screw from a board, and you are given two hypotheses, right, of how does this process happen, removing a screw from a board, and the model has to basically choose the correct hypothesis. So in this case, we see a pretty big jump in terms of using video distillation knowledge. Another example is how to grow a plant. And then Tracy is a temporal common sense sort of reasoning task where the idea is that the model needs to understand which events happened in what order. So if the context is a long, complicated context of Tim visiting his grandparents, they didn't have Wi-Fi, their connection still used dial-up, blah, blah, blah. Basically, given a complex sort of context or premise, the hypothesis is that dial-up internet is not as good. This certain event happened or started before Tim visited his grandparents. So event one versus event two, which one happened before the other one? That's sort of the task or the job that the model has to do. So here also, we see big gains using video knowledge distillation. And then I'll skip some of the visualizations, but here we showed that if you just do some kind of text to video retrieval visualization, then the left side is showing the teacher model, which is obviously very good at, in this case, the query is about cooking with different ingredients, and the teacher model, which has been trained on video data, is very good at finding very highly relevant videos. But on the right side, the student model, which technically has never seen any video data, right? It only gets distillation from the teacher's language model, also is pretty good at discovering and retrieving cooking related videos. And here it's something related to crafts, for example. And so the teacher model versus the student model on the right side. Okay, so this is where I'm going to sort of end the talk. This is the last part of the talk on efficiency. So the problem here is the same motivation that I gave in the beginning of the talk, that when you're working with multimodality, right, vision and language, the problem of large-scale language models becoming too large is much bigger of an issue, right? Because especially with images and videos, as you see in some of the next slides, these models get even more infeasibly larger. So not just billions, but trillions of parameters. So the problem is that we have to focus on how to bring efficiency into these models. So one example I already showed was unification, right? So unification is one way to reduce the redundancy by having unnecessarily specialized and overtuned and different kinds of architectures and models. But can we also add other kinds of parameter efficient training methods on top of this, right, for more efficient parameter and memory updates? So this is a recap of one kind of efficiency that I already showed in the talk, where if you're doing unification through, say, language generation, you could in VLT5 have 1/7 of the parameters while still having comparable performance on very different discriminative and generative tasks. But what about parameter efficiency based methods, right? Things like adapters. So this is what we did in VL adapter at CVPR this year. So this is probably the first method that's trying to get into how do we do adapter style efficiency when you have both a language and model, a huge language model, as well as a very large vision model. And so the question that we ask ourselves is that usually these vision encoders and language models, like I said, bring even more amounts of parameters than language models alone. So can we learn this V and L fusion knowledge, right? That's sort of the main thing we're trying to do, like make sure that the interactions are being learned correctly. Can we learn this fusion knowledge without tuning the whole model? And the answer is yes. So the left side is basically where the full language model's parameters are updated, and you can get around 77.6 VQ accuracy, whereas on the right side, with just 4% parameter updates with adapters, you can still retain similar accuracy. And I mean, not just on VQA, but even video and language tasks, as I'll show briefly in the next 2 slides. So this is the process of how we use adapters here. So this is, first of all, we are using ClipT5, which is the clip version of the VLT5 model that I showed. And what adapters do are, adapters are these bottleneck modules. So you see this, if you see my pointer, this basically has a downsampling and upsampling bottleneck process. And if you insert these adapters between the layers of your model, what you can do is only the adapters and the layer norms are being updated. Everything else which looks gray and blue is frozen. And then you can also try different kinds of adapters, like hyperformers use hyper networks to learn the adapter weights, and compactors are the kind of adapter that further use matrix decomposition to compress the adapter weights. And then another thing you need to think about is whether when you add these adapters across different kinds of tasks, do you want these to be unshared adapters for specialization when you're updating only the adapter parameters, or do you want them to be completely opposite of like a single completely shared adapter, or something in between, which is that each adapter comes with a shared part and an unshared part. So the results are very surprising and positive, where what we show is that with the simplest possible setting, where you actually have a single adapter shared across all tasks, with just 4% parameter updates, you can actually achieve almost the same performance on average, 77.6 versus 77.4, as compared to full fine tuning with 100% parameter updates. And these are some pretty different tasks like VQA, GQA, NLVR2, COCO captioning, and so on. And then the other good thing is that when you're sharing adapters versus unsharing or half sharing them, the single completely shared adapters also give you the biggest improvements on the smallest data sets, like NLVR2, which is an intuitive advantage, right, of having shared adapters, because then the smallest data sets get more shared knowledge. And lastly, it also performs better than more complicated settings like compactors, hyperformers, but also in context learning like prompting methods and LoRa. And finally, this also does well on video and language tasks like video question answering and video captioning. So again, you get basically on average the exact same performance as full fine tuning with just 3% parameter updates. And the last example I'll give here for efficiency is on the video and language side. So this is also a big problem that's basically faced the community for the last maybe 2 years, where the problem is that when you go to videos, efficiency issues become even much bigger. What most of the setups were doing when you were trying to build a video and language pre-trained model was that you would basically have yeah, I guess I'll take questions quick soon. But basically, the idea here is that what you would do is you would, when you're having these video encoders and text encoders, and then you have a cross-modal encoder, you would actually have to stop the gradient when you're trying to do backward updates. So in some sense, you're using offline extracted dense video features and text features because it was just too expensive to backpropagate and update the video encoder features. And this brings 2 major drawbacks. One is that there'll be a big disconnect in the video features that are originally being used versus the ones that are needed for the task domain, right? Because they're not getting updated. And second of all, you cannot use, if you're taking these video features and using them for, say, a very different video and language task, then also there'll be a big mismatch. So what's one possible solution? The problem, as I mentioned, is you cannot do what if you first want to do end-to-end fine-tuning of the whole backbone, right? That's impossible, because if you see the first bullet, that's not scalable to clips, right? Even for a short 20-second video, extracting features every 2 seconds, you are basically running through the whole vision encoder 10 times, which is very expensive, right? Much more expensive than language encoders. And then also what you could think of is you can take advantage of the fact, like one simple solution is you can use sparse sampling, right? So you can take advantage of the fact that you are basically having a lot of redundant information in adjacent frames. So what you can do is you can just sparsely sample a few clips from the longer video, and you can do clip level predictions first, and then combine this information to the full video level prediction. So basically that's the idea here. Like if you break this into these 3 samples as an example, then you can actually update the video encoder and backpropagate all the way back through to the video encoder. So the summary of the results here is that on things like text to video retrieval, using this clipbert approach with sampling, you can actually perform better than the state-of-the-art pre-training models than like ActBert and Hero. And also on things like video question answering, you again can outperform these more expensive models while still using fewer frames
We have connection.
Hello? Hello?
Okay, we see you now. Can you hear us?
Yeah, I think I lost you for a second.
Yes.
So did you still see this last slide?
This one, no, it was still kind of the clipboard. The one.
Okay.
Yeah, I think we saw something like this.
Okay, yeah. So this is the last slide of the talk. So what I was saying is that the last thing. So this is very recent, hot off the press from NeurIPS last week, and the last kind of efficiency that I'll talk about is efficiency through audio. So what we've been looking at is a big problem in the video and language community is that you use these automatic speech sort of recognition based subtitles, right, for the videos, and they are very notoriously noisy and misaligned with the video time steps and so on. So what we said is, let's see whether we can do textless vision language transformers, which means that let's see if we can skip all these ASR and tokenization and all text-based modules, which will bring in both efficiency, but also allow homogeneity, right? So the idea here will be that if we are basically not using any text modules, we are going to see whether we can treat audio spectrograms as directly images and do the same kind of masked autoencoding objective on both images and audio spectrograms. And so the answer is yes. We showed that you can get comparable performance without using any text modules, and at the same time getting around 30 times inference speed and 1/3 of the parameters. So this is a summary of basically what I'm trying to say, that instead we basically bypass the ASR and other text modules and this text modality and directly go to the audio with the vision side. And the model basically looks like this, where, like I said, you basically do vision transformer style patch embeddings for both the video and the audio. So the bottom side is the video patch, and the top side is audio spectrograms that are also being treated as images. And then you have this joint multimodal encoder as well as shared weight decoders, but you have to have two decoders because you're reconstructing the audio spectrogram images versus the video frame images, but they still have shared weights. And then you use the contrastive learning objective and the masked auto-encoding objective. And as you can see on this slide, the model is actually pretty good at reconstruction. So this is from the video side where you patch a lot of information and the reconstruction is pretty close to the original. I mean, at the feature level, right? This is not for text to video generation. This is for masked auto-encoding pre-training. And then also for the audio side, the reconstruction after masking parts of the spectrogram are high quality. And so that's the basic idea here. I'll not go into the results, but we show that audio-based textless TVLT can perform competitively with text-based TVLT on many diverse tasks like image retrieval, video retrieval, visual question answering, multimodal sentiment analysis, emotion analysis, and so on, with 30 times speed and 1/3 of the parameters. So I'll skip this and then just come to my conclusion slide. So this is sort of a quick summary of some of the next big challenges and research directions that we should be thinking about, and a lot of us are already working on this in the community. So some of these will be, so I'm sure, part of the panel as sort of fodder. So this is basically some of the top questions in the slide are asking us to think about whether unification and universal models versus specialized models, right? What kind of trade-offs do we need to think about unifying everything? Obviously, it comes with good efficiency, but what are situations where specialized models are much maybe better than having unified models? And this connects to the second bullet of strengths and limitations of large-scale pre-training, right? So in some sense, would you rather have something that's modular and versus completely pre-trained with layers? And right, so it connects to issues like interpretability and data quality and so on. And then the third bullet is also related, where should we rely on everything as large-scale pre-training, or should we also rely on structured modular knowledge, right? So for example, in the like things like knowledge graphs, right? Do we need those? How much benefit have they shown currently in current results in the community versus just rediscovering all that information directly from tons and tons of data, but with this data quality and interpretability issue? And this becomes an even bigger challenge in multimodality, right? We have to think about whether we will have enough information to learn all kinds of information for different modalities, especially for other modalities that I mentioned in the next bullet, right? Like what about nonverbal modalities, gesture, pointing, gaze, things like action and interaction, right? Most of us learn through interaction with the world. So will we have good enough simulators where we can actually throw a model and let it discover things in the world, as opposed to learning from videos, which is the current surrogate, right, that we relied on as the closest sort of approximation to more simulated embodied environments. And then also bigger sort of modality combinations like documents, right? So which will basically have text, images, infographics, and so on. And then the last few bullets are discussing more higher level questions of what about the right way to evaluate these models, right? So I was not able to cover that part of the work in today's talk, but we have some work showing that a lot of these video-based tasks actually do not need long-distance understanding, which might have to span, say, different episodes of a TV show, right, to understand a trajectory of a relationship and so on. So basically, this is a big problem where the current benchmarks, most of them do not even need long distance understanding. So like how do we go about better evaluating our video and language understanding models? Same for common sense reasoning. There's been a lot of good work in terms of common sense benchmarks, but then we need much more of those on the multimodal side too, especially in terms of causality and counterfactuality, right? We want to make sure that the model is not just coming up with the right answer out of multiple choices by accident, but it should be able to explain why it came up with this answer. And more importantly, if we change certain very important parts in the premise or the situation, it should be able to change its answer for the right reason, right? So we have some new work showing how to get improvements in models, like how to make them right for the right reasons. And then fine-grained skill evaluation and bias evaluation. So you've been surrounded by, I mean, I'll not go into ChatGPT because a lot of the discussions already centered around that in our world right now. But a similar situation that you've seen on Twitter around you probably is tons and tons of automatically generated texts and images and videos, right, from all these image generation models. but no one's been was talking about the evaluation of these models. So we had this work called DALI eval earlier this year, which basically tries to show that most of these models are extremely bad at compositionally, even simple things like putting something X like a red block on the right of a green cube versus left of. And also we also showed how to do things like gender and skin tone bias evaluation. So yeah, so I think I'll end there. I mean, the last couple of slides are also good questions for the panel. In some sense, most of these models are not good at continual learning, right? These still store a lot of old information, but then when the information is wrong currently, how do you unlearn? How do you make the model unlearn this information and also correct itself, right? As opposed to just digesting more and more data and then averaging that information somehow and coming up with some randomly correct answer by chance. Yeah, and then I already covered a lot of efficiency questions, but there are a lot of other efficiency dimensions to think about, not just number of parameters and memory, but also other kinds of efficiency. So I'll stop there. Thanks.
Any questions for Mohit? Yes, Shari.
Can you hear me? Yeah.
Yeah.
Thank you, Mohit. This is a great work, a massive work. So I have two questions. You answered the first one when you showed that you can integrate the audio with the visual and having like an embedding for the audio signals and be able to have it as a cross transformer with both of them.
Mm-hmm.
My second question is, if we want to change, to apply the same model on different language, what do you see the impact of that? And the language could be other languages than English that have resources, or maybe like a low resource language, like an Arabic. What kinds of changes that you can see either with visual and language text, or even with audio and visual?
Yeah, so I think for the audio part, I think it's a benefit, right? Because you are going to rely, like I said, the whole, there were two goals here, right? One is to not rely on noisy and less readily available text modules, right? So or good speech to text systems and also good tokenizers and so on. So hopefully that well aligns with low resource scenarios, where if you're avoiding the relying on modules that are not available in low resource languages, I think this could be a good paradigm for that. And then on the text and multimodal side, yeah, it's still the exact same issues, right? I mean, we basically one good thing is that there's been a lot of work on this area called multimodal machine translation, right, where images have been used as bridges for better translation. So the data scarcity for low resource languages will still be an issue, but at least you have a second modality to rely on here, right? So in some sense, whenever the text side of the other language falls into the sort of not enough category, right, at least you have this bridge of other modalities like images and videos to be able to learn some of the gaps. So I feel like in general, both the image and the vision and text scenario and the vision and audio scenarios better align with low resource language issues than pure text scenarios.
Yeah, that makes sense. Thank you.
Thanks.
No, yeah. Hi, Mohit. Thanks for a
Hi,
great
Barbara.
presentation. Hey, hi.
Thanks.
I was wondering, a bit puzzled by the vocalization work where you predict for each token, right? The image. I was wondering two things. One is, do you really do that for every token, or do you keep out like very,
Yeah, so that's a
close
great
class
question.
item?
Yeah, I think I get that question every time I give this talk. So that's the
Okay. And
so yeah,
maybe connected to that
yeah.
is a second bigger question. Do you think, for also early work in machine translation, you mentioned just now, where we didn't see so clear effect on adding the image. Do you think we need that granularity or something in between, token, image, something hierarchical? What have we not found the right ways to fuse language and image yet. And is this the right way to go?
Thanks. Yeah, great question. Yeah, so the first answer is that yes, I mean, the reason why we did contextual vocalization was because some words are very naturally visual, right? So they will be able to find their visual mapping much more robustly and easily. Whereas the reason to do this contextually was that some words, even though they are going to be able to find a visual mapping, will not be able to do it at a type level, but they will be able to do it because of the context that they learn at when you make it contextualized tokens. So that increased, we have some nice ablation in the paper where that increases the coverage a lot. So you get many more words getting good visual mappings because of this contextualization, but there'll still be words like prepositions, certain kinds of prepositions, right? I mean, in fact, even spatial prepositions are visual, but there will be other prepositions that will not need a visual mapping. So yeah, so this is basically a nice kind of almost like a hyperparameter that you can use, where you can even have something where you only allow the sort of top X% confident visual mappings to be used. But it's exactly the same corollary to masked language modeling, right? You do not need to mask everything because a lot of the fill in the blanks actually cannot happen, right? Even with the surrounding words, or they will not improve the model. So there have been follow-up works, right, that try to show what to mask in masked language modeling. So same thing here, right? What to visually map. And then your second question is, yeah, a nice sort of panel question maybe, is that, yeah, so there's been a lot of like work in terms of multimodal machine translation. I think I mean, I don't really, I feel like here for the visual vocalization work, we were more focused on showing whether pure text tasks can be improved by adding visual information. So in this particular line of work, we did not try machine translation multimodally. But if you see the VLT5 work, right, you do get a lot of improvements on multimodal machine translation because we unified it with all other kinds of visual question answering and referring expression and other kinds of captioning tasks. But in terms of vocalization, maybe I'm not an expert on multimodal machine translation, but I'm not sure if the video version has been tried yet, right? So we saw much better improvements, like I showed in the second part of that talk, right? Where when we did video-based knowledge distillation, we saw much better improvements because videos cover much more diverse concepts and non-static concepts, but also the knowledge distillation objectives are much stronger. So my suspicion is maybe if the multimodal machine translation kind of work was using videos as the bridge, not images, which I'm assuming there's not that much of with my limited knowledge about that sub area, we probably will see much better gains because videos have much better sort of simulation of the real world than because when we use these images in multimodal machine translation data sets, they're also coming from a very specific domain. Right, so that hampers a lot of the improvements because they're not able to cover in diverse enough domains and concepts. Whereas when we do the video work, it always comes from the largest possible sort of how to 100M and YouTube 120M kind of very in the wild open domain videos that try to cover as much concepts as they can. Hope that answers part of it.
Okay. Other questions? Yes, Tim has a question.
Hey, mate. A content bias question, maybe. So, you know, obviously in adding extra modalities, you sort of get extra views on the data. And, you know, we sort of all know in terms of textual data, you know, there are things which are so you know, plainly obvious that you would never spell them out, you know, the classic sort of yellow banana sorts of examples. But, you know, videos or images, you're also going to have content biases in terms of the sorts of things that people will tend to video or not video. It's maybe a philosophical question, but
you'll be surprised today on like how much that's more of a joke. I think everything's being videoed these days, but I understand the question.
Well, I guess there's at least going to be an exposure bias.
Yeah,
Be,
right,
you know, all you know, 50% of children are under the age of 3,
yeah.
or you know, these sorts of things, right?
Yeah.
So yeah, what impacts does that have on the sort of language modeling side of things when you're doing multimodal model training, or you know, is there sort of some compensation element there between sort of the textual biases and the content biases on the
exactly,
video and the
I think
side of things?
Yeah, I think your second part of the question is the first part of my answer, where basically the complementarity between the two biases, first of all, helps because some things are naturally more written, even with content bias as text, and some things are naturally more visual. So they are seen more in images and videos on the web that people take. But even after that, there will still be some subset of information that's neither present on the text side or the visual side. And so that's part of where one of my last bullets was coming in, where we do need to expand this into other. So that's why we started going into audio, right? So when we are starting to look at all the information also directly on the audio side, there is a lot of information that, first of all, it will capture as background noise and sentiment and emotion features. And that paper has a lot of details about tasks which need all this kind of information, and you see big gains there. So that's sort of one direction, right? And then there's so much more, right? There's things like gesture, gaze, action and interaction, right? So sort of action and reaction, haptics. So there's sort of this unlimited sort of spectrum of modalities that we've not touched. So that will cover hopefully some of the remaining part of the bias. But after all of this, there'll always be still something that's just never recorded, right? So that's where my bullet on whether we still need structural modular knowledge graph kind of knowledge hopefully comes in, where we do need this. Maybe that's maybe the holy grail of like where curated knowledge will finally be shown to be useful, right? Because that maybe everything else we can assume will be captured by raw data, but then that sort of like everything minus all the content bias, right? That remaining portion might need to be curated manually.
Okay, other questions? Okay, so if we have no other questions, let's thank the speaker again.
Thanks again for having me.
And now I give the microphone to Jimmy.
Yes, indeed. Thank you very much, Mohit. So we now switch over to the panel. Just bear with us for a couple of minutes as we do some frantic furniture rearrangement to create spaces for our mini panelists. And we will then kick things off. And I've sort of done a very clumsy attempt at trying to identify common themes or possibly provocative questions. We'll see how we go with that. And then I will open the floor to questions from all of you. Just while we're waiting for chairs to arrive, I have to share the panel was almost 7 in-person speakers plus Preslove plus Dan Roth, just to sort of get the royal treatment. But Dan very sadly missed his flight connection in London, so we're with Dan Roth. Okay, we opened the curtain back up. You didn't see all of the furniture removal, really. And here we are again, the final act. What was the final act going to be? Was it, I can't remember, were we going to have, sorry? Suicide, hopefully not. I can't remember if we had a tragedy or a comedy in our final act. So let me try to distill out some questions. So one thing which came up from, well, at least Yejin, Barbara, Ed as well. But I guess it's sort of so fundamental to what we do as a field. I think it cross-cuts everything. Labeling. So, obviously sort of labeled data sets are fundamental to what we do. Are we going about it the wrong way? So there were sort of suggestions that discrete label sets are not the right way at all. So should everything be instructional? There was a question from Barbara about sort of disagreement and modeling disagreement and capturing it in our evaluation metrics. Should we allow people to choose their own label? So sort of not necessarily completely open-ended, write your own text, but out of a selection of different label sets, choose your own, choose the one which makes the most sense to you. You're an ordinal person, I'm a hierarchical person, Preslav's a Likert scale person, whatever it is, and we sort of make sense of it after the fact. Can we, rather than forcing people to adapt to our norms in terms of what data should look like, should we be kind of going back to square one and completely redoing it in line with sort of throwing out supervised learning, a la Yejin? I'm interested in responses. Possibly Yejin and Barbara, because it sort of came up sort of most centrally in your presentations.
Yeah, I have suddenly mixed feelings about labels, especially starting last year. Before then, I didn't really second guess. I thought that's how we're supposed to be doing research, labeling things. And but then I realized the common sense knowledge and reasoning that I studied working on is one case in which it's impossible to create a predefined taxonomy of labels that will cover everything. It's almost as if there's just infinitely many labels that are in the form of a free text. I encounter a lot of such actual examples when I do that. So then it becomes more like generation task. Common sense reasoning becomes generation task. And it's never the case that we only have 1 million common sense inferences to choose from. You cannot just define 1 million and then hope that it's going to cover everything. So in that sense, it's almost like infinitely many common sense inferences that we are choosing from on the fly. So that's one thing. And then the other such realization happened as I look at more and more of nuanced task, especially toxicity and hate speech that Dee is working on. In some cases, people disagree. Annotators can disagree whether something is microaggression or not, depending on their wokeness, depending on their cultural background as well. In some culture, maybe something is not a hate speech. In other culture, it totally is. So that's when I realized these things are not entirely binary. Might be that we need to allow for more distribution of labels. But then, I was wondering, does the distribution of labels always work in the case of, say, hate speech detection? And I come to realize that that's also not the case, because sometimes I might see two different labels simultaneously, depending on how I might interpret, or I might be able to explain why that's the case, in which case I might actually want to say both labels simultaneously, but with a different reasoning, which means that there has to be, again, natural language generation as a part of the output. And that's what humans are perfectly capable of doing in our day-to-day lives. So we can reason about things, we can discuss things. So in that sense, I was having more and more mixed feeling about labels. Just not enough.
Yeah, I think this works, right? Yeah, great question, of course. So I think in general, I believe like supervised learning and some labeling will stay. We will not go just to make you like a counter argument here. I think just going to do everything with generation type of models, sequence to sequence models is not there. We need some tasks where there is more like a categorization system or more like a classification system. Like information extraction is one of the examples, even though you can do it as generation nowadays. So I think we will stick still with a while with labeling, but how we do it and how we then measure the quality of these labels, that's kind of what we need to rethink, I think, because we cannot just continue assuming the same annotator agreement scores, the same kind of thresholds for acceptance for all of the tasks. This is important things to clarify, but there is also a balance, right? For some tasks, there is, you need more fine-grained categories, but where to stop is very, very difficult when you add a new category and so on. And this is a lot of effort. So also looking deeper onto the annotation cycles, doing several of those, going back more to that groundwork is, I think, very important, but also going to see if we can complement them with distributions or more soft, multi-label schemes and so on to get more out than assuming, okay, we have a categorization, which is, I think you said it, fluid, wasn't it that? You mentioned that at some point. Categories are fluid. Yeah, so sometimes they are fluid, often they are fluid, even almost all the time they are fluid, I would say. So we need to certainly rethink of this problem.
Okay, so I'd like to add something. In certain cases, you don't want to commit to a fixed inventory of labels. So I had this situation when I was trying to interpret the semantics of noun compounds. So things like, I don't know, what is olive oil? Well, it's olive extracted from oils or olive from oils and stuff like that. But I can actually kind of paraphrase with all kinds of verbs. And then we have even at some point a shared task. We asked people to produce all possible paraphrases, kind of, their systems. And then for something like onion tears, you get like tears that come from chopping, that onions give you when you chop them or something like that, I mean, you see something very, very complex, right? And it's not really coming from an inventory. Then another interesting thing is that in many cases you don't control the labels, and it's not about you producing them, and it might be very, very expensive for you actually to produce them because it might require domain knowledge. This happens when you work, for example, with biomedical databases. So what of those protein-protein interactions and whatever, they're written by humans and they are not designed to be machine readable. And there are many issues with that, right? So kind of like, and yet another thing is, more recently when I started working on fact-checking, there are many, many different inventories and different fact-checking organizations. Now, fact-checking one claim can take a day or two, sometimes a week, okay, by professionals. And most fact-checking organizations have a capacity of one claim per day or two claims per day. And you cannot crowdsource it. You cannot annotate it yourself because you're not qualified to do it. So you have to work with what is available. It is not that much that is available. It's available, I don't know, the biggest one have like, I don't know, 15, 20,000 claims, but the others have like just a few hundred, okay? And now you want to get something from, let's say, 200, 300 different organizations, but everybody has their inventory. Some have 2 labels, 3 labels, but some have kind of something much more complicated. 2 Pinocchios, 3 Pinocchios, or out of context, or mostly true, half true, probably true, and all this kind of thing. So what do you do? Well, one solution is what I don't know, kind of, let's say Isabel Ogenstein was working, saying, okay, we are going to have label embeddings, and we are going to internally kind of not try to map them manually. We are going to learn from all this, and we're going to learn embeddings for the labels. And then if you want, at the end, you can project into the inventory that we want to use. So, I mean, just so I can note that kind of, it's in certain situations, it's not an option. We have to work with what is there.
So I do a lot of work on syntax, so I'm a labeler from way back. And but I think there's a big difference between that situation where you really have an agreed set of labels. They may be very misleading labels, but you have an agreed set. And I think there's a big difference between that kind of situation and the hate speech situation, where I think that as Yejin said, the data is inherently uncertain and that the idea of labels doesn't apply. If you have labels, then you should do supervised learning because, you know, in the area of syntax, unsupervised grammar induction has not worked. And I think there's a very good reason why it hasn't worked. But if you don't have labels, and I agree with Yejin that distributional labels probably don't help, then you probably should go on unsupervised.
Thank you. I'm very much in line with that. So I think the evaluation depends heavily on the tasks. So in linguistics, many areas there are quite clear-cut decisions that are regulated by theory. But in human behavior, and hate speech is just one specific example, there's just like a lot of uncertainty depending on contextual factors. So that's why it's hard, next to impossible, to evaluate that in this formal way. And I remember our work on argument mining, we always assume humans are a good model. However, humans are terribly bad at identifying or constructing arguments. So depending on the tasks, the human may be a good or a bad model. And so I argue for a plurality of approaches towards evaluating the system. For example, in evaluating humans, we can, psychologists, try to measure how much the humans learn. So if you have multiple kids in a class, so some kids learn a lot, other kids do not learn well. So there are some ways how to measure the learning, the quality of the learning process. And maybe this is something we need to think more about, since we are interested in developing systems that can continuously learn. So that needs a different evaluation paradigm.
Okay, since I bring up the hate speech topic, I could comment on this. Yeah, I agree with what have been discussed. The other thing from my own background, from a human-facing or socially aware perspective, I think it's to think about behind the label, who are creating those labels. Distribution of labels will work well if we know which groups are being represented in the process, but in many cases we don't know. So I think in the current annotation paradigm, a lot of times we are vague in terms of who are our annotators, who are the human. The human could be expert with linguistic knowledge, could also be Turkers we hired from Abzim and Turk, which we don't know much about their background. So who really produced the label for us? Who are representative for the task we really want to do? I think those are key questions to think about. The other thing is, since it's really uncertain, we could take a step back and maybe make it more proactive in a way that we can select who to include in the annotation process. There was a great work I shared with Barbara earlier this morning called the jury learning. So the key idea is that when it comes to something very subjective like hate speech, maybe we could form a jury. There might be different people we could recruit, and they the voices in this process. They could be random, or they could represent certain groups or factors we care about. And then giving the policy, giving the context, let the jury decide what's the right decision for the current instance. So maybe sometimes a little bit more human-centered or proactive could be a good way to approach labeling.
Yeah, Ginger.
I wanted to just make a minor correction about what I said. I'm not so binary about supervised learning. I am very fluid about supervised learning. It depends. And also labeling, I do label. I still create new labels. So I'm not against it. It's just I was complaining about the more single-minded fascination toward it as the correct way of doing science, because when I was in my early career, I was almost told that unless I have a high human agreement score, I shouldn't work on problem. In fact, somebody even told me that don't work on summarization problem because you cannot really evaluate it reliably. You cannot even define what a good summary is so that two people can agree upon. If we go by that way of defining NLP scope, we probably should work on primarily syntax. And never mind the generation or pragmatics. And about syntax, by the way, so I got this idea about even part of speech text being squishy due to Chris Manning's ACL presidential speech, I think was 2000, maybe 16, thank you, or so, in which he cited this old linguistics paper in that said basically even such basic categories are squishy, and the squish was in the title of the paper, I think. I don't know if you wanted to add something to it or not. But... Oh, yeah. So, I mean, even like a verb, noun, I think one thing I realize is this, the labels are very distinct, and it does make sense in a very clean-cut sense when we think about them in an abstract way. The moment we try to annotate an example, we start to seeing slippery slopes in reality. And so that's what I was referring to. And in which case, there's this question of how important is it to train annotators to agree upon one way of doing labels so that there's a high human annotator agreement to score we can report, and then machines should only learn that way, versus what if we actually treated that as more fluid category and then let the machine deal with it? And especially with the larger models, it seems that they're more and more comfortable with this kind of noisy labels in the data. So who knows what happens with the modern deep learning?
So it's quite true that so part of speech labels are notoriously unreliable, and what you should do about that is you should take the thing that people are good at labeling and bypass anything that they're bad at labeling. And in fact, what you can do to solve this problem is to work at the syntactic level using a distributional model of the labels. And using a large language model or an LSTM or something like that to resolve the ambiguity. And actually the best performing parsers bypass that level of labeling. So there's a real, I mean, it's the problem that was referred to earlier. There's a real problem. There's a difference between having a good set of labels and being able to actually apply those labels. Agreed. But bypass, never trust parts of speech.
So very quickly, I want to add something, 2 points. One is that related to, okay, we don't know how to evaluate summarization. We don't know how to evaluate translation, right? There are tasks that are hard, and we're kind of used to it. And we have ways, okay, pyramid methods, multiple references and all that, right? But there are other situations. So if you look at dialects, for example, Arabic dialects, languages that are not even written, what does it mean to do speech recognition for a non-written language? What does it mean, right? You have to transcribe it somehow, but how? What is the writing system? And then when people do this transcribe Arabic dialects, now do you try to follow the that you write it in standard Arabic? Do you want to be phonetically there's no rule. And then in Arabic, and if you don't write the short vowels, and then when you start writing this word, to me, it sounds like a short vowel. I'm not going to write a vowel. To you, it sounds like a long vowel. I'm going to write a vowel. So there's no agreement. It's not clear what is your target, right? That's one thing. The other thing is, when we do annotations with labels, we are used to do annotation with small number of labels, right? With, let's say, 3, 5 annotators, something like that. But what happens if we have 100 annotators? Okay. Now, we are used to be suspicious about disagreement. But as we get more annotators, we should be suspicious about agreement, because the probability that everybody agrees on a label goes down. And actually in certain cultures, right, the legislation system with some kind of, old kind of people in the antiquity, they had this kind of rule that if everybody in the jury says this person is guilty, the person walks free, because they knew that it cannot be the case. It cannot be so many people in the jury. Everybody thinks that this person is guilty. We are missing something just because of the laws of probabilities.
Last comment from Barbara, the next question.
Last addition to this, I would like to just mention as well that I would say disagreement or human label variation we can find in almost any task. So it's almost impossible to find a task where we're pretty sure there's just one single agreed label on for all labels that we give every annotator we would give it through. So, but definitely there is this amount of variation that we can find according to the task. That's important. But another thing that I would like to bring up is while I'm not working on generation, this is something that I believe is also very important for the generation side, because in a way what Shinji was saying, generating more diverse output will be much more important in future, and our decoding algorithm, even our references are impoverished, right? If you think about talking to MT people, hey, I was surprised to hear how few data sets they have with multiple annotations, or how often they even evaluate against multiple references, or trying to solve better evaluation metrics to capture this variation, even in paraphrasing or non-paraphrastic translations. You can name it. There's so much more to be done in this variation and capturing this, not just in the labeling, but also in generation models. I think this is a huge thing that hopefully we get better in the future.
So next question, and yes, maybe my budget is going to be 2 more questions at most. And it's a slightly squished one, so hopefully you can make sense of it, as in I'm sort of combining together lots of things. So I was sort of struck by so various comments about, Ed, you were talking about this idea of sort of deep common sense knowledge. I mean, Yejin, you were sort of talking about reinforcement learning and sort of reward signals. I mean, it sort of came up, when you were talking about sort of social interaction. It came up in Mohit's talk in terms of sort of grounding, but where am I going with this? Do we have the objective functions, the reward signals, the task formulations, whatever it is? It's a sort of, I think, a broad scope of different things. I mean, Claire, you're also talking about sort of, we need to do things at the document level. We can't just fixate on the sentence level. I think we've all sort of been sort of a mixture of amazed and horrified at how far we've got with masked language model objectives. There's a glass ceiling. There must be a glass ceiling. It's just a much, much higher glass ceiling than we might have thought. What are sort of other rewards, objectives, tasks? What are we sort of not thinking of because we're too sort of fixated on what is data settable and what is leaderboardable and what is evaluatable? As I said, it's very open-ended and somewhat squished. Ed.
I don't quite know what to say. I think we have been so brainwashed into our rather simplistic approaches in NLP, and we're so happy with what we can do that we ignore the fact that most systems that do very well on standard data sets, when you put them in the real world, they fail completely. and you spend another 10 years trying to make the system really work, even though something which you thought was great and perfect. And that's a common story in NLP. So our little simplified data sets and things just don't cut it. So going to the performance from the beginning is probably a much better strategy for us. Then you have to say, and this is something from the previous question, just why are you labeling? And if you're labeling just because you're used to labeling, that's a stupid idea. But if you're labeling because you believe for this task, it's important to separate A from B, then that's a good idea. And then you must prove that it's a good idea. So I can for any task, I can make the label set, is there a T in what I'm showing you, or is there no T? Right? There's a binary classification, and we all agree it's a stupid label, right? So there are lots of labelings that are stupid or not respecting the task, but you can do lots of labels depending on what you do on the same data. There's not a single correct, truthful data labeling, is it? So when you say, okay, when we have we mustn't jump to a little task and be so happy with it and do a little labeling and do a data set and say, okay, it's done now. So now we all run after this data set and we do it and we get our little basic result and we think we're great and we have the little competitions. It's just not that simple, right? I think that's the answer.
I think the NLP has got far away from the user, actually, and we want to serve the user at the end of the day, and we evaluate on some proxy tasks that do not translate to this performance. So we have a huge bias towards big data tasks, something you can label at all, right? Because many things are very hard to label and it's much too expensive and you can't create a big data set. You can only work with very little data. So maybe the bias should be somehow corrected to the other way. Small data domains and user-based evaluation. Everybody hates doing that because it's a lot of work. But I don't see how we can close this gap between what we have and performance in real life scenarios if we are not touching this problem. So that's a very fundamental question.
As much as I said something against the labeling, so long as we broaden the scope of labeling, and then when we do so, sometimes we go crazy with it, there might be something good about it. And even the, ChatGPT and whatnot, it's amazing because of the data and labels that they did do on top of the original pre-trained mask language models. And at the raw version of it, these pre-trained mask language models don't do what they're capable of. It's only after trained on a diverse set of, different data and instructions and a lot of these human labels, or more like a human feedback, it then performs well. So a glimpse of it is OpenAI had this summarization paper based on their PPO, proximal policy optimization work. And what was really striking to me about that work was the amount of human feedback they collected through crowdsourcing. So they collected summarization, quality, judgments. If I remember right, some in the order of hundreds of thousands of evaluation. I mean, we don't usually think that big. And that allowed them to train extremely high quality reward network, which was trained almost like in a supervised way. So again, I'm not against the supervised learning if it's a component to a bigger picture, but then using the reward network, instead of having to rely on human evaluation all the time, now they are able to do more fun stuff with reinforcement learning. So I do think that when we think about labeling, maybe it's not just about sitting down and then somehow define categories that everybody can agree upon, but we might need to think bigger about what else we could label that could then maybe used as almost like objective function for the purpose of reinforcement learning or for the purpose of other things. So that's one thought there.
I'll follow up on that. I was going to bring up the same paper. One problem there is that they didn't release any of their human feedback. And so to do something like what Ed wants, and I agree would be useful, taking the systems that you have and putting them out in the wild and getting human feedback that then you can somehow use maybe within this sort of framework. It's really hard. They needed a lot of human, they needed summaries, and they of them. They're really hard to get. So I think this is a hard thing.
So can I add a little thing? Sorry, I think one of the biggest values of labeling for me is to teach me about the problem of the structure of the information in the domain. So when I have a thing and I assign a bunch of labels, I design my system. I think it's true. I run it through the annotators. It never is correct. I have never, ever seen an annotation scheme that works the first or the second or the third time. Never. I don't trust anybody who says I designed it and it worked the first time. I think they just don't know what they're doing. I just don't trust it. So you say, well, okay, and now I begin to understand that this is a kind of a simple thing to do for people. This is a hard thing. This is a very squishy thing. This is a contingent thing on some other third label or second or fourth label. You design all this stuff and you begin to learn what's going on in your domain in informational structure as it reflects to human understanding. Then separately, you have to say, what's my task? And is this labeling system actually relevant to the task? And sometimes the labeling system is much more ornate and careful than I need. People can just look at it and say, yeah, this works for me or this doesn't. You may have to have 100,000 decisions because if you can't go and design a careful little labeling scheme down to get exactly the right feature because it's too hard, then you just have to give a lot of it to the big engines and they will find their generalizations. But it's good to teach you what to do with it. And then you have to give it to people, I think.
I wanted to comment on the fact that OpenAI didn't share their reward annotation, which is somewhat frustrating, if not very frustrating. But it's something doable within academia if we actually wanted to really create such a data set in the following sense. I was so a lot of these data sets or annotations that I've done over the past few years on common sense benchmarks or atomic common sense knowledge graph or social chemistry, which is about complex annotations on social norms and whatnot. It was all funding that I raised, not what AI paid by and large, but the DARPA MCS program that supported the crowdsourcing. And I went crazy early on in the program that I wanted to do a lot of crowdsourcing, and the program manager was definitely uncomfortable about the amount I was asking for, but I was inspired by Martha Palmer. I had this intuition. AMR or, prop bank, all these resources were incredibly expensive resources. And, someone went ahead and asked for the money in the first place. And I think the common practice is that don't ask a lot of crowdsourcing money, just ask for student array. But maybe we should ask for more money for crowdsourcing. And I mean, DARPA can pay. Maybe AI took a nap.
Let me perhaps just ask one last, slightly Dorothy Dixer question, because it was something I was asked on an AACL panel a couple of weeks ago, which I was sort of slightly horrified that the question was even asked, but I think it's sort of somewhat representative of the younger generation. And I think partly this workshop and your presentations have answered the question in itself, but the question was, as a young researcher, what's left to do? Pre-trained language models solve everything. There are transformers. The field is done. As I say, Dorothy Dixer question, responses to that to pep up the younger generation. I know I have my own responses, but I'm asking the question.
Can I give you my favorite task? Read the Wikipedia pages about World War II and summarize them, pretending that I, the reader, am a 5-year-old, a 9-year-old, a Japanese speaker whose English is not good, somebody Jewish, somebody who is an expert historian, and just a normal kind of person who has to write an essay. Make me those summaries, decide how long, decide at what level, decide all this stuff, and give me a summary, give it to these people, and just see how much it do little tests and sort of questionnaires afterwards. I've never seen an NLP system that can do that.
So I'm not sure what the question was exactly,
The
but
question was,
I'll answer it anyway.
Even better.
I think that the most important question to address is the question of common sense knowledge that in the form that Ed raised the question in his talk. And I don't think that any of the assumptions about history having ended with the large language models is going to solve that problem. So I think that is what you should answer. And also to warn people in connection with the last question that intrinsic evaluation, as Ed said as well, is for telling you whether you're doing any better than you were yesterday and comparing yourself with others by releasing the evaluation data set. But being the head of a leaderboard on that data set is just a waste of time.
So actually, I find it quite optimistic that people are asking this question. And I'll tell you why. Because again, this comes back to something that was mentioned during the presentations, that if you think of the history of machine learning, initially we had rule-based systems, then we had, let's rule on those kind of manually annotate examples. Okay, maybe with deep learning, maybe without deep learning, this kind of detail. But now you can actually learn from human instructions, right? And kind of from human explanation of the problem. Not only that, you can have one model. Kind of, we are going in the direction of more general models that are capable of solving multiple tasks. Now, you cannot probably, and it was mentioned, you can go quite high. The glass ceiling is quite high with just masked language model, and kind of there's also kind of different variations of masking and all that. But people understand that you need to. I mean, the Da Vinci and all these in GPT-3, they're fine-tuned on quite a few tasks, and we have now like T5, 1,800 tasks and all that, right? It was released like last month, and so you do want a lot of additional training, but if you think about it, what do you want? You want a system to understand human language, and you want to move away from simple classification. That's one thing. The other thing is more generally in AI. What do you want? You want to be able to the system to understand you, and you don't want to have a separate system for every single task and for every single domain and for every single label inventory. It's just crazy, right? So I find it quite optimistic that people are buying into that. And I mean, the dangerous part is that people don't quite understand how it works. Even specialists don't understand certain aspects. And we all understand that this is some kind of magic and this kind of magical thinking. This is the dangerous part. But I like the idea that we do have now a model that can solve multiple tasks. And this is, I mean, that might, and I think that this has opened a very interesting research direction. It might be, I don't think that the transformers are the end of history for NLP. Actually, I have written an article that has this kind of transformers, the end of history for NLP. That was the title, right? So anyway, so I mean, I think that would be the same kind of like Fukuyama declaring the end of history, you know, after the fall of communism, because nothing interesting is going to happen from now on, right? I mean, and we see that things are happening. So I'm sure that it will be the same in NLP.
All right, so I would say there is still a lot to be done, and I would encourage people to work on edge cases, like working with little data, or actually even more broadly re-question the assumptions we take at the current stage. Like there's so much to be done still on, you know, byte pair encoding, how we tokenize, and okay, there are some approaches, but why that, and question these assumptions. Similarly to the human liberation, right? We take this assumption, or why do we take this assumption? So going back to these questions that we take for granted, similarly like data, I really like work more in data difficulty levels of like these data maps that we heard about today. So there's much more in that space than in just the modeling itself and trying to find a new transform or whatever, 0.0.
Yeah, maybe adding on that, for such a students who feel intimidated or depressed by the extreme scale neural models, the art of the war. I mean, choose your battles, like, you know, work on edge problems or hard problems, and then know your enemy, meaning know how to fail, make a trick GPT-3 or chat GPT, whatever, fail at your favorite adversarial questions, and then think about how you might address it differently, and then innovate your weapons. So algorithms and data, I mean, there's just so much more we can do. It's a really exciting time, especially because there's something beginning to really work, and promise, I mean, like, trust me, it's more exciting time now compared to when I was doing PhD, when a lot of us were doing feature engineering. Yeah,
we had fun, Eugene.
I was having fun with you, but I mean, you know, I would suffer so much trying to make features better, and then it does it do somewhat better, and it was hard making the sentiment analysis work. Very
so
hard.
I think a response to this student, I guess it was a student, of course. They're just not thinking that creatively, and so if you need problems to work on and think that everything works well in NLP now, one fun thing to do, and actually a bunch of the open problems that were raised, EDS for sure, scripts, plans, goals, where does that come from? Go back and look at the old ACL papers, and you'll be amazed at the difficulty and the breadth of the problems that were getting looked at, and that couldn't really be handled. So people would design a system that handled a single document. That's their PhD thesis, but we haven't been able to go back to those and really do the right thing. So I'd say there are thousands of problems.
I want to say something different. Okay, I share the same concern as what this student is asking, maybe because we are all the young generations. I think many things are real and true. The pressure is real. The pace of research is real. The impressive performance of all these big models are real. We talk about, I think first, a lot of the research we are talking about today could provide potential directions for the next step. But think about something different. For example, edge cases such as bias or fairness issues. I know a lot of students were working on that, trying very hard at the biasing techniques. And then ChatGPT came out. You see that bias detection got reduced a lot. And then you could have creative algorithms next month, or maybe next week, GPT-4 came out. All your research are there. So you are not a state of art anymore. Yes, you understand something. So I think there are just like a lot of practical parts that are real. And this is not something I think can be easily resolved. But then on the other side, I feel like this is an inflection point. This is an inflection point. Maybe it means this is time to change what we mean by a good research direction. And this is maybe some resources I think the community could offer to help people navigate this real emotion, real concern, and a real struggle with this type of environment.
So basically the question is how to design a good research agenda in the time of large language models. So to paraphrase that a bit, So there's, for example, one wonderful topic, efficiency. The models get larger and larger, but they are inaccessible, they are too expensive, and there are many issues. So perfect topic for academia, how all this great performance, but with much less resources. And I'm sure there are many more research questions like that to identify, to make useful research.
Maybe I can add something else. There are different ways to do good research. Maybe kind of it goes back to this question, right? So one is I have this new super good algorithm. There's this very well studied task. There's tons of literature and all that, and they just come with this super good approach. That, yeah, and the kind of the shelf life of those papers might be short because, especially now, you know, it's not anymore the state of the art. It is kind of the main contribution, right? But kind of maybe you have now a new technique, a new development that can be applicable to many things, and like Ted was talking about that, right? So then this kind of one way. Another way is actually to look. I mean, is to look into, well, is this the right problem? Is this the right question that people are asking to kind of, you know, really looking more into the application? Now that we have tools, there are many more problems that we can look at. I mean, I can give you an example. Let's say from my area, fake news, you know, disinformation and all that. Okay, we can look into fact checking. Okay, is this true or not? Or you can look into an article, is this fake news or not? And this kind of where most people stop thinking, right? But there are other problems. What is interesting to fact check? I'm a fact checker, right? I want to know what are the interesting tweets, or kind of there was a political debate just finished. Normally I can check one claim per day, but now I have all these journalists over the night, they can check me 10 claims. Which claims I'm going to pick, right? I mean, that's a different problem. Or was this fact checked before? Or kind of instead of checking a claim or check an article, check an entire website. Can I trust this website? Or check an entire kind of coordinated group of users. I mean, can I trust these users, right? Or looking into kind of how exactly I'm being convinced, you know, okay, all this propaganda at the article level. Well, why? What are the specific techniques that are being used there? So, and then kind of, you know, what is the framing or other things? Kind of, you can actually define additional tasks, or for example, kind of looking into, well, let's see now, I mean, let's look into memes. And in the memes, you have like the text, you have the image, you have the connections between them, and it can be something much more complex. I mean, to say that a meme is hateful, that's not so easy. It's not about, oh, there's an apple in the image, and therefore, you know, the answer is one or something like that. It's kind of, you need to have much bigger understanding. So what I would say is that one way to go is to look into other formulations of the problem, kind of into other ways to look at that, and not necessarily to, and then the large language models are just the tool.
Just one sentence.
Response, yep.
One sentence. I think a characteristic of people who have a lot of imagination and who are slightly older and more experienced is they ask why, not how. And a characteristic of people who are younger and are still learning to play the piano, they ask how, but not why. So when somebody says it's all done, he's asking a how question. Just have them ask why questions, and there's a million open things.
Wonderful. I'm conscious of the fact that we're 3 questions and 50 something minutes in, and we have very flagging, jet-lagged panelists, but I'm not going to shortchange you in terms of interacting them. Perhaps I can suggest we change up the format slightly when I open it to the floor. So perhaps questions to individual panelists with the option to have one response for another panelist, just to get the throughput going a little bit more. Otherwise, we'll only need to have time for one more question, I suspect. So given that constraint, questions? No, it's 1-to-1. One is not all.
Okay, so I guess like just a quick comment and then maybe a question. So for the last question that, you know, we've been trying to answer as to like what problems to work on and so on. And I think, you know, like what Prislav said is about, you know, finding new tasks and, you know, that goes also along the lines of many of the problems that people have discussed. So text reframing and things like this. I think one thing that seems to be like absent is I don't know, like send this student to do a minor in a different field. Like I like this idea of, take 2 to 3 courses in psychology or like whatever other, and then I think like just going that way will inspire a lot of diversity and creativity and thinking and so on. So my question actually, like I'm actually inviting comment in that direction, like, the educational part of this. Yeah. So, and I'm not gonna ask any specific person. Maybe if somebody feels like passionate about this, they can go for it. Yeah.
I will go, but I won't have that much to say. I brought up the same thing in my talk. And so I tell students to do this all the time. Go somewhere else and look at, if you're looking at fact checking, well, go see how journalists do it. Go see how, newspapers handle it. And they always come back with some ideas. So I think going to other fields to see how they study and think about the topics that we're working on is a great source of ideas.
So I rushed back to the workshop because I do have a question I want to put in front of the experts, right? So in the past, AI, NLP, has been focusing on study mechanisms and building models and, designing algorithms. Now we are reaching to a phase that the big language models are producing contents. Like in other science, chemistry, biology, when you start building contents or producing kind of products, there is a question of how to undo it. For example, in chemistry, you have a lot of pesticides and the chemical compounds into the soil. And now we are, after 50 years of using that, we are worried about how to undo it because it was not done right. So here we have a lot of contents, artificial articles, conversations, and many things which are now being generated. And in the cyberspace, once they are generated, they are there. You cannot delete it. So imagine 50 years from now, or maybe even 10 years from now, is there a possibility that 90% or 99% of the web contents are actually the generated materials from those big models? I ask this because it's very different from the old days where we have database, we have search engine, which is to get us into that original material. They don't generate anything. Right now, language model is producing stuff that is very hard for people to tell whether they are by people or by a machine. So I want to ask the question that in our study of big language model or any other NLP problem in the future, when we are at the phase of producing material, is there a boundary that we should produce something and not produce something? Or if we produce the wrong thing, there is a way to undo it, or we just leave it for future generation to solve?
I have 2 comments about this question. So first, for example, in fact checking, the source of information is crucial for evaluating the information. And I don't believe we can stop this from happening, that the language models produce contents, but we need legal regulation. We need transparency. What is inside of contents that we consume? Similar to when we go to the supermarket, we have a label that describes the ingredients of the product that we are buying. So I think the legal regulation is one point. Another point is I was struck by a recent conversation with an educational researcher in Germany, whose research is about how to teach people to post-correct automatically produce contents. So she told me there are many apps around that can write an essay for a student or can solve maths homework. And in future, they assume we live with this technology and we cannot stop students from using it. But a lot of content produced automatically has many mistakes, and it's crucial to educate the new generation how to post-correct that contents rather than prohibit using such apps. So probably we need to think about the future reality when we have this technology around us. And then the question is how to integrate it reasonably in our daily lives.
regulations, geneticists not to generate certain viruses. At least it's illegal, right? So I was trying to see in our own research in AI, so far we're not getting used to, doing our research under certain regulation or boundary. And do you see a need for that in the future?
Yeah, I think it's, well, the question is it the same scale problem as the comparison that you are making? And is it feasible to establish a national consensus about this?
That's exactly why I'm asking, because the productivity, of a computerized agent is way higher, than any of our conventional approach. Therefore, the risk is even higher. So I thought a greater need of a regulation, than in biology and in chemistry. After all, those productions are slower. And in here, I can imagine without control, in a year, the full cyberspace will be kind of contaminated or infested with generated materials. And that's something which I feel very scary, because my children may never have a chance to read any new material or real material from human if we don't really tell them which is right, which is not.
So if you look at the Twitter space, of course, there are people who are writing code to try to identify who are the bots and who are not, right? So I think one can regulate all you want, and I think some people are just going to ignore it. So we live in a world where we're going to have to do steganography on not only text, but also images, or all the deep fakes and things like this, and a lot of people working on that. It's just a fact of life. We've polluted our information sphere thanks to us, our own work, right? And it's never, we're never going to unpollute it forever. It doesn't matter how much we do regulations. So we have to write pollution finders and pollution removers, and we'll do it too. But it may be the case that the good things that slip through are so good that they're equivalent to Jane Austen in any case. So it doesn't matter if my kids read this one or that one. I don't know.
I think that one thing that we need to be asking, right? I mean, okay, so I agree that we cannot really stop it. I mean, we can stop it in certain countries, we cannot stop it in other countries. And if the internet remains open, if it does not disintegrate into national internets, right? I mean, again, it's hard to do it. So you can limit it. You can limit many negative things, right? You can put things under control. Spam was a big problem 20 years ago. It's not a problem anymore because everybody agreed that was a bad thing. Now, does everybody agree that fake news is a bad thing? Does everybody agree that computer-generated art is a bad thing, or computer-generated, like, fake user profiles and all that? I mean, like, fake images are great for advertisement campaigns or for many other things. So kind of there is good uses. I think that the defining thing is it harmful or not? And if it's harmful, then we should be concerned. Actually, there can be a good use of this technology. And, if there is an automatic program that is going to generate for me a summary of what happened in the last soccer match yesterday, or what happened in the stock exchange, be it. And this is a technology that has been there in the major newspapers for years, and nobody has complained about it because it's harmless. So, I mean, I think that we should look into the whether it is harmful or not. And this is something that has happened, for example, in the fake news space. People initially were talking about fake news. What is fake? Well, sounds like false news. Focus on factuality. Then people realize, start talking about disinformation, something that is both false and harmful. And more recently, people talk about infodemic, where the focus is only on whether it's harmful or not, and whether it's true or not is kind of secondary. And I think that now with the we are kind of going into kind of being concerned about, to me, the equally important, if not the more important problem. Is it harmful or not?
Okay, I think that's a great question. I always think about this as well. Not only just like passive reading information online and then the fake information there. I think it's an existing issue already, even before large language models. We have bots, we have all this kind of, even like human who are employed to write content online. So the cyberspace is already full of sort of spam and trash. So this is not a new question. The new challenges that might be introduced by large pre-trained models, to me, I think that there are two. First is that if the data gets polluted enough, then all the bigger models we are going to train that will be based on this type of fake or spam content. That's going to create a greater threat to the society. So that's one part. I think either by having some additional models to tell whether the information is of good quality or not. The other thing is, I really like the copyright thing that DALL-E 2 has. So basically there is a signature associated with any generated content. I don't know whether from a policy or regulation perspective to give a signature for content or disclosure for content generated. So that might provide one thing. The other dimension is more about how to use. So passive online content reading is one action. What's more dangerous is this interaction level. Think about, I really enjoy this workshop. I'm going to write an email to a team using ChatGPT in a very touching, very sincere way. Will you be thanked in that way? If I don't tell you, if I tell you, how would that influence all the dynamics? How would that create a disruptive consequence to all the humanities? I think that's a bigger question.
Yeah, so I would like to dig deep one step further into the common sense knowledge, like the innate learning versus learning from scratch. What kinds of structure that we want to put into our models to make it closer to the natural language understanding, and the trade-off between put this structure versus something like reinforcement learning, where you want the model to learn from scratch. In other words, what we want to be learned and what wants to be explored. What is the trade-off between these two, which brings to the maybe a bigger umbrella of how much knowledge should we bring from neuroscience and cognitive science and bring it to our model in order to reach to the point of natural understanding and thinking about it.
It's a big question. Yejin?
Yeah, great question. I don't think it's one or the other. Though I want to say something about reinforcement learning, although I was very excited about that. Without knowledge about how the world works, the paperclip maximizer, as we know, can try to maximize paper clips and, end the humanity. And we might then think, oh yeah, change the objective function so that while maximizing paper clips don't kill people, is that enough? The answer is no, because then it might go ahead and not kill people, but maybe cut all the trees out. And it doesn't, maybe the model doesn't necessarily realize the consequence of doing so. And it's only common sense knowledge that we already know that, of course, you shouldn't do obvious things that's going to destroy the environment entirely. And so when we learn, we really rely on this rich background knowledge about how the world works. And I don't think reinforcement learning, just learning from scratch in a simulation environment will go very far. It's only going to work when it's relying on pre-trained language models, when it's relying on maybe reward network trained on large amount of human annotation. Maybe simulation data might help to some degree, but that alone doesn't really go very far. In fact, I noticed that a lot of reinforcement learning people who used to think language is not relevant for them started using pre-trained language models as some kind of guidance for their policy learning. And so it's been a bit of a trend among these people who don't actually care about language problems, but they love pre-trained language models for their reinforcement learning problems. The other aspect about this common sense knowledge, so then how do we do that? Should we maybe look at neuroscience and then try to mimic human brain? I don't know whether it's very much possible to really mimic, in the sense that maybe there's a limited understanding about how the brain is even structured to begin with for the purpose of building similar neural network. But I do draw inspirations from development psychology, where, for example, Lisa Spelke had this theory about core knowledge that even infants do have different conceptual understanding about actions versus agents versus time and location, space and whatnot. These are separate concepts that are learned separately in some sense, as opposed to pre-trained neural language models that just treat any token equally. So it's likely that we do somehow need to better address temporal reasoning, spatial reasoning, object permanence, and all these like different types of categories of concepts somehow differently, but it's not clear how exactly we're going to do that just yet.
Mark, as the president.
So to follow up on what Yejin said, because I'm going to agree with it, I think that the thing that cognitive science has to tell us about the subject that we're all studying, natural language, there is an underlying cognitive language of mind that underpins natural language. And it's the source that the child who learns their first language, which could be any language of the world, is drawing on. And it is a language for understanding exactly such basic aspects of the world as what an agent is, the fact that things can only be in one place at the same time, I mean, one place at a time. And I think that we should be very careful about thinking that we can learn that. I think we certainly can't learn it from text. I'm actually doubtful that we can learn it from grounding in the world, which was also mentioned in the earlier discussions, because it's a structure that you need in order to understand your grounding in the world. And I think that it is something that is not learned by the child, but has been very specifically developed by evolution over a much longer period of time than the human race has existed, or even the primate order has existed. And I think that investigating that language of mind is a very hard problem that we haven't even begun to really understand. And I think there were earlier attempts that we should learn from. As Claire said earlier, there's a lot of old literature that failed because it didn't have access to neural models of the kind that we have. But there's a great deal of wisdom in that early work, in those early failures. The topic of co-reference was mentioned. I mean, I think that is something that is at this level, and where there are some good old ideas that we could bring into our very crude span-based models of co-reference that we're using at the moment, that as in an earlier discussion, really won't scale to a lot of the problems that we need them to scale to, such as long documents or dialogue, which is a kind of long document. So I think that's what cognitive science has to offer to the position that we find ourselves in now.
So Mark, can I follow up on this? So imagine today, when you start a new training session, you have your big machine, you randomize, right, and you train. Imagine tomorrow, instead of doing that, you preload some fundamental framework concepts or something, and anything you train on top sort of gets interpreted in those lights. What would you put in there as the fundamental framework stuff? So what comes to my mind is something about time, right? The temporality, right? Something about space, and something about not occupying the same space at the same time, and things like that. Something, as Jejin was saying, about agency versus patiency, something like that. Something about elemental nice and elemental not nice, sort of the basic sentiment poles, right? Something about that. Something about negation as being sort of blocking something. Something of these very primitive. The question is, how do you put those things in such a way that anything that comes later finds its right home and touches there? That's one question. And the second question is, let's say you can, and let's say things that come in now trained and they have this extra flavor. There's the red zone and the green zone and the blue zone, and now you train this machine, you've got, you've got GPT-3, but every little thing in there has a slight redness and a greenness and a blueness and all this stuff. What do you do with that?
So I think that we do have one thing going for us, which is whatever the semantics of real languages that we experience shows us. Because we know from the child learning the language that the languages we see where in one language a verb will be a verb will have to be replaced by a sequence of verbs in another language. We know that all of those languages much pile into this hidden language of mind, and that is a good guide. But I think that the biggest obstacle to actually seeing our way through natural semantics to that underlying cognitive representation is that we don't have, I mean, you mentioned time. I don't think we understand our understanding of time at all. I think it's actually not at all like clock time, and I think it's not at all like temporal logics that are used in computer science. It's actually primordially to do with causation and ideas of agency that come up in Spelke's work that was mentioned earlier. And I think that we face a very difficult problem in sort of walking the cat back to that primordial language. And I think we need some really good ideas about, you know, formal representations of knowledge that we have never had so far.
I suggest we move on to one last question before we completely wear out our panelists. James?
Thank you. Just bring on to the last point about representation of knowledge. Where should that be? We see that knowledge can be represented in parameters of large-scale language models. And I'm thinking of things like the Llama language models as knowledge-based probes. But also know that in all of open domain QA, we find external knowledge from textual sources like Wikipedia and use that to condition generation in models. We can update our models by doing knowledge editing, but that's a slow or a difficult process and a lot more challenging and a lot less interpretable than just changing the prompt we put to our model. So should we be representing our knowledge as text or these axioms of time or locality or object permanence or things like that? Or should we be representing our knowledge through parameters implicitly or explicitly or some mixture of these?
I might dare to. Yeah, that's a interesting question. So I do like the idea of using language as the medium of intermediate, to some degree, as a medium of representation, because at least we understand what that means, so that we can introspect what the machine knows and even being able to make some edits to it. Whereas the moment we define yet some other language, maybe, you know, some like symbolic redefinition of all the conceptual understanding about how the world works, we just miserably fail is what actually happened many times over and over. So I don't believe that there's any other language that we are capable of creating that's equivalent to natural language. And then there's, of course, knowledge that's not easily expressible by natural language. So that's one challenge. Even like time, we can describe a lot of knowledge about time and, you know, how long a conference typically takes and what happens in between. And this is very much like event script knowledge and all that mixed with the understanding of time. But that's not how necessarily what the underlying neural representation will look like, and it's not clear how it should look even. But it seems to me that at least the input-output of that learning experience might be in a great deal in natural language. And in fact, humans learn that way too. Like we don't know how we store knowledge, but we do learn through language a lot, input, output, and ask questions even. So I envision, like, just dream about wishful thought that one day neural network can actually ask clarification questions, or even being able to really ask a deep per questions about what it doesn't know. But that seems pretty far. I don't think GPT-4 will do that.
I think we may have finally exhausted our panelists. They're silenced by that one. At the start of this workshop, I joked about going until 8:30. It was meant as a joke. It's now almost 6:30. We've gone on an hour longer than what we were supposed to. As much as I would like to go on until 8:30 or 10:30, I think that might be stretching the patience of our amazing speakers. So with that, please join me in thanking all of our speakers again and panelists. We have gifts for each of you, if you'll stay there for a moment.